All right, we're going to get started in just a minute. All right, hello everyone. This is the TLS working group meeting at IETF 100 here in Singapore. Let's see. You should all be pretty familiar with the note well. Since this is Thursday, you've probably seen it 10, 15 times already. But please respect it. We do have minute takers and jabber scribes. The blue sheets are going around. Remember when you speak at the mic to state your name, and let's, as always, keep this professional. Are there comments from the peanut gallery down there? You know, it's the professionals. Good. All right, here's our proposed agenda. We do have a fairly packed agenda, especially since we want to get to resolution on the remaining TLS 1.3 issues and make progress on DTLS as well. A couple other drafts, especially the IANA registry draft. We also want to start moving that forward. Document status.
If I can find my slides here, where are they? All right, so we got 2 docs in the RC queue. It's misref. They're waiting on another reference. So we're about done with those. That's great. The Dane draft should be ready to go. So that's really good because we've been kind of pinging them a little bit. Since the last meeting, we adopted 3 drafts for delegated credentials, SNI encryption, the record size limit extension. I think the delegated credentials and the SNI encryption stuff is still in its infancy, getting to get worked. But Martin, do you want to say anything about the record size limit extension draft?
Yeah, Martin Thompson. I think this is done. So I think we're done. It was kind of blocked on an issue that was on TLS 1.3 about record sizes that we discovered. That's recently been merged, and that was the only thing I was waiting for.
All right.
I have an implementation if anyone wants to do interrupt testing on that one. Cool. I talked to a bunch of people. It's a little tricky to implement sometimes because you have to restructure the code a little bit, but it was worth it. So. Okay, great. So we're going to probably go ahead and work in group last call that one, hopefully by tomorrow. There hasn't been a whole lot of discussion on the list, but I think it was a pretty straightforward change, and basically nobody said don't do this at this point. So be ready for that. TLS 1.3 has been through 2 working group last calls at this point. We're going to discuss some changes today, and then we'll probably end up having to do another targeted working group last call. So we're just talking about the new changes since last time. And we have, we'll talk about later today, that we think Joe and I are writing that draft, that the IANA registration update document is ready to go. We'll have to identify a shepherd since we can't shepherd our own documents. And we'll have to make sure Kathleen hits the button for us because she has that power. Because again, we shouldn't be progressing our own documents. In progress is DTLS 1.3. We're going to hear about that later. We got an example of handshakes for TLS 1.3. That draft is going to get pumped out once we get TLS 1.3 out the door. Apparently, it's pretty easy to get going. The Greece draft has expired, but David said he was going to update it yesterday, so we'll see. And today we're going to talk about exported authenticators for TLS, and TLS certificate compression extension isn't on the agenda, but it's still an active work group draft. And that's it. Any other questions? Ta-da. Thanks.
So hopefully it's the very last, the really, really last time I have to stand up and talk about TLS 1.3. Next slide. So there's only 3 things I want to talk about. The only important thing really is this middle box issues thing. So, and then we can talk briefly, and things keep trickling in because we keep not closing the draft. So hopefully once we close the draft, then things will stop trickling in. Next slide. So as I sort of said in the email, we're finding that middle boxes sometimes appear to be kind of sad when you negotiate TLS 1.3. So we have some more data later, but this is our initial data from Firefox beta in a forced test versus Cloudflare, by which I mean Cloudflare. Yes, Ben.
Just for the chairs, are the slides in the data tracker somewhere?
So what I mean by a forced test is basically a forced A/B test. So we have a Cloudflare set of Cloudflare servers that are essentially identically configured between well, some do TLS 1.3 and some don't, but otherwise they're identical. And we just basically do a request to both of them and look at the error rates. So that way as opposed to organic testing, which I think David will be talking about later with the Chrome. This, by the way, notice these organic error rates like incredibly high. That's like what everybody seems to see. You can drive these numbers down a little bit. I was looking at some of our numbers earlier today, and some of the problem is like China blocking things. So like when we do force tests against Gmail, like if you like remove China, like the error rate goes way down. But nevertheless, the organic error rate from TLS is pretty high. Regardless, we're not willing to take a 1.7 or a 0.7 or a point, or this is not a 1.7 hit to deploy TLS 1.3. And so if we were to do this as a browser, we needed to continue to do fallback, by which I mean we need to somehow probe whether your environment could do TLS 1.3, and if not, we need to do TLS 1.2. There's a bunch of ways to do that. One way to do it would be to do it with every connection. One way to do it would be to do it like a captive port detector, but regardless, you have to do something. Now, opinions on whether this is like just crappy differ, but regardless, I think there's a general consensus to be better to not have to do it if we possibly could. And so the Chrome team, or the boarding team, based on a suggestion by Kyle Nekritz, has been working to figure out how to get rid of this, and basically how to screw around with the TLS, with the non-cryptographic parts of TLS 1.3 to make it look enough like TLS 1.2. The mailboxes go, oh, and they just let it through. The order of operations here is I'm going to talk briefly about the PR that I've written based on their work and some feedback from other people, and just walk you through what it involves doing, and then David's going to talk briefly about the data that Chrome has gathered. Next slide. So there are 2 parts of this PR. One is the things you always do, and the other is the things you can do but you don't have to do. The parts that you always do generally look pretty reasonable, and are things that would have been reasonable design decisions that we just didn't do when we did 1.3 initially. We had a long discussion. The first one is how to do version negotiation. So we had a long discussion initially about when we did supported versions, about where the server should acknowledge which version it wanted, and we sort of people went back and forth between it should be in the server's extension, supported version extension, or it should be in the server hello version. And we eventually shoved it in server hello version because that seemed like the more normal thing. And even though it was a little odd to have a thing and then respond in some other place, it turns out that's bad. So the proposal is to just revert that decision, which is to say to have the server hello version, the main version field be TLS 1.2, and then to have support indicate the actual version you're selecting. The second change, we had, because we thought they were not necessary, removed session ID and the compression fields in the server hello, because there's no compression and there's no session resumption. And so they seem, and there's always some little who weren't sure this was a great idea. It is kind of a pain in your parser, by the way, because you have to have a conditional part of your parser. So, again, and then the next point is, remember we nailed down the record version layer to 0301, which represents TLS 1.0, and it turns out that you don't want that if you're going to claim you're negotiating TLS 1.2. Basically after the server hello you use 0303 instead of 0301. And again, there's nothing particularly crazy about this choice. It's just that you made the wrong choice initially. So those are reasonably design decisions we just could have made differently. We just didn't.
Is there any intuition why 0303 instead of 0304?
Yeah, yeah. If you, because you're claiming to be TLS 1.2. So in the supported version, in the server hello. So now we get to the things which are like a little less like happy. It turns out, and there's like some. So I don't think we actually have measurements that if we like HR, it can be a handshake type that like nobody's gonna recognize, they're gonna completely freak out. And so the proposal here is to and HR and server hello essentially have overlapping pieces of information. And so the idea here is to merge HR and server hello into a single message, and you can tell what it is basically by looking at a special Sentinel random value. Like I'm not going to defend this to you as like an aesthetic design choice. I'm simply going to say like I want hello, I want HR on a work way to make it work. This Martin did is not ridiculous. It's just like annoying.
Yeah, Martin Thompson, one thing I observed was that some of the code that deals with the values in the server hello actually make some sense in the hello retry request processing. All the extensions are different.
Yeah.
It's a little bit weird, but it's not, that's not the worst part of this design.
Right. Yes, exactly. So, okay. So this last thing I'm going to say isn't going to make any sense until you see the next slide, but you have to do it, otherwise it doesn't work, which is you have to ignore any time you receive a change cipher spec message during the handshake. You have to just throw it away. The reason you're going to need that is because the next slide, please, which is that if you think your boxes, you have to do what we call compatibility mode. And what compatibility mode is this. You pretend a session resumption. So you make a fake session ID value, which I think we said is random, but like it doesn't have to be random. It just to be like not like obviously like all zeros or something. And the server echoes it as if it was doing resumption. And then basically you send change cipher spec messages in the appropriate happening if you were doing like if you're doing resumption. Namely, the server sends one right after the server hello, because that's where you cut over to the finished, and the client like sometime after the client hello. If you're doing like one RTT, you do it like basically when you're at the beginning of your second flight. If you're doing 0 RTT, you hopefully do it at the beginning, right after the thing client hello. We don't have measurement that second thing works, but like people with a 0 RTT fail punks out that like you just retry with 1 RTT. If that happens occasionally, it's not a disaster. Because that's not an insecure fallback. It's just annoying. And you have to be willing to fall back. Like every browser stack basically. And if you're doing 0 RTT, you're probably going to sorry. Anyone who does 0 RTT has to be willing to deal with like a bunch of error conditions when like, the server didn't like 0 RTT. And like every browser stack retries, and so like retrying there is really easy. So as I say, you don't have to do this, and you wouldn't do this in DTLS, and you wouldn't do it like in the quick embed. But you would do it like if you were like right behind in the box. Initially, I sort of envisioned this as each side had a unilateral compatibility mode, and that's almost entirely true. But Martin Thompson points out that the client's the one who's got the middle box, because the client kind of wants to tell the server like you really should be sending the CCS. And so what is in this PR, what we should change is that the server receives the non-empty session ID. It should generate the CCS in any case.
Yeah, Martin Thompson, though, I observed that if the client doesn't do these extra compatibility hacks, there's basically nothing you can do at the server end to repair things.
Right.
So it has to be the client that initiates this behavior. And if the client knows there's a middle box there and the server doesn't follow along, then it's just going to fail.
Yeah, exactly.
And I suggested must, in fact, on this one.
I think
and we can.
I put in should, must would be fine too. Yeah, I didn't want to fight about it.
But yeah, this is
No,
must. If the session ID is present in the client hello, the server must send a change cipher spec at the appropriate points. Right. Would be my suggestion.
Part of why I resisted a must is going to come in this next slide, which I don't want the client to have to enforce.
So, come again?
Part of why I resisted a must is that a lot of people think that must means that the other side should have to enforce, and I don't want the client to have to enforce.
I certainly don't want an enforcement. Right. Yeah. Okay. There's a line to walk there. I don't
really
care.
Other than that, I don't care if you should. Right. Kyle.
Kyle backwards. One thing to note is that the server does not necessarily know that the session ID is a fake session ID. It could be a real one from previous TLS connection. So it seems a little bit odd to put a must send this
Fair enough.
behavior in response to that.
Yes, fair enough. Yeah, I think if you're going to switch hit here, you're going to have to like have some way to distinguish random session IDs from non-random session. And that's actually an argument for why we should require them to be random appearing.
And it's, so if the client knows that it's not behind a middle box, it wouldn't send a fake session ID, and then it wouldn't create this ugly.
It would most likely not get this, yeah. And we could actually say should not too, because it doesn't do any good to have it. It probably doesn't do any good otherwise. Nothing.
Let me, Andreas. Question just for clarification. I haven't followed this whole discussion, but are you trying to make it look to the middle box as if session resumption is being done?
Yes.
Okay. If the middle box does not have the session ID, it's going to reset it.
So some middle boxes do that, but apparently our experience has been that it's sufficiently infrequent that things work okay. Right? David's going to talk about the data.
I mean, it all depends on the policy that's configured. I'm just telling you, right?
Yeah.
That would
No,
happen.
we're aware this is a risk.
Okay.
This is about getting the error rate low enough that we're willing to make those middle boxes change. I mean, to be clear, those middle boxes have like as their responsibility ultimately. Like those middle boxes are basically broken, right? Those middle boxes. So okay, so let's take a step back. The middle boxes we're dealing with are defective. What I mean by that is they are not properly handling TLS. Not properly handling TLS version negotiation. If they were properly handling TLS version negotiation, then they would have worked fine. So the problem is they're defective, and so if you if they properly, so what I mean by that is when they receive the client hello, the responsibility is either to do version negotiation and downgrade to 1.2, which would be fine, or to not do version negotiation and not screw the data. But what they're doing is an intermediate thing where they're basically passing through the extensions that are recognized and then mirroring the server's version, or they're trying to do state machine inspection at the wrong version level, and all those things are busted. So all middle box has to do correctly is it has to actually do version negotiation. It works fine.
So I don't want to argue, what's correct or what's incorrect, right? I'm just trying to give you some feedback
Sure.
as to what might happen in real life,
Yeah.
which I understand is your concern. You're trying to deal with that.
Sure. Yeah. Well, as I say, if those middle boxes are implementing version negotiation, then this will all work great. Even without this, it worked fine.
So Martin Thompson, another thing to observe here is that in the case of a hello retry request, we're not as certain that it's going to work.
Right.
None of the experiments that we did actually implemented that. And it looks slightly different on the wire as a result of the fact that there's a handshake message that appears
Afterwards, right.
the CCS. Ordinarily, we encrypt all of the messages that come after this CCS, and they just look like application data, and they look like TLS12 application data records, and for all intents and purposes,
Yes.
the middle box is happy. It's a session resumption. But in the case of hello retry request,
That's
it's
right.
a little bit different. Again, it's a risk I think we're willing to take.
Yeah.
It's not working. There's a red light on it.
There's a red light. Should-
So now that everything looks like 1.2, we're not doing version negotiation the old way with 1.3. Are we introducing a possible problem with making that problem worse with
As soon as we did supported versions, that was the problem. I mean, basically the problem is you to be concrete, you shouldn't be forwarding extensions you don't recognize. Is the problem. And if you're doing that, you're gonna have problems. So yes, we hoisted version negotiation. Like we hoisted version negotiation out. Basically, we don't actually have measurements on what happened if we tried to use the over negotiation mechanism, but we do know it caused problems with servers. So we hoisted it out. That may have contributed problems here, but I think that at this point we have to like double down on that rather than backing out. I see people.
Bjorn Metzdorf, Apple. I brought this question up during the hackathon as well. I'm wondering if we should include a recommendation to, let me call this, the compatibility mode, to not try to engage in compatibility mode on the first request. Because if we did do that, then ossification will always be the case and nobody will adapt to pure TLS 1.3.
Yeah. I guess I don't think people are any willing to have. I don't. I guess I'm not sure people are any willing to have it be dramatically slower on every connection for behind middle boxes. What we've been thinking of doing is basically giving you a basically running the captive portal detector and giving you a saying your middle box is busted. Why don't you complain to your vendor? Instead of trying to basically penalize you in every connection. We've been thinking about.
I think that I spoke to some implementers, and I think the agreement is that they want to do this anyway. I'm just wondering if we should put in a recommendation and address the issue of ossification specifically.
Yeah, my sense is David is not very sanguine about this, about the project getting out of compatibility mode.
David Benjamin. So the data is a little bit confusing on this front, but we have some reason to believe some of these middle boxes are a little stateful, and if you offend them, they will black hole you, which kind of makes fallbacks problematic. I'm also generally skeptical that like adding a fallback is going to convince them to do anything because hey, it works, and they probably won't even realize something's going on.
So we that I think I can measure that staple question. I think I'm able to measure because that our experiments lend themselves well to that kind of measurement.
Ritz. I think that we should just not put any recommendation in this, and then deployments are going to do what they do. And if it seems like a reasonable way to move things towards better compatibility, then deployments will do that. I don't think a recommendation is really going to affect it anyway.
Okay. Anything else? Okay. Next slide. Yeah, to say what happened here. Right. So there were a couple issues raised here about how we ought to do this. The list. So several people said we should only have the compatibility mode. I'm not enthusiastic about this for several reasons. First, as I say, we don't need it for TLS 1.3 quick or DTLS, and so corrupting up those protocols is annoying. The data is extremely fuzzy, and that's why this italic is here on whether you need client-side CCS or not. I don't think we quite understand that, but it's possible you might not need it, and should you keep having it forever? And I think this is the last bit is more like unicorns and fairies, but at some point we might actually get enough people fixing their mailboxes that we can stop sending server-side CCS. David is shaking his head no, but I mean, as I said, unicorns and fairies. So it should be sad if we ever in that situation to have a situation. So I guess I don't know if anybody wants to sort of speak up for only compatibility mode. Okay, I guess then since people did raise that on the list, I don't know. Do you want to? Oh, you're gonna pick up for it? You just want a mic? Right. So I guess I mean, do you want to given? I guess can we at least record for the minutes that people were not in favor of only having compatibility mode because like we're gonna need because like otherwise it's gonna be like fighting down the list with no consensus for it. Do you want hum or?
Yes. I think it's easier to implement anyway, not having to enforce anything.
All right. So, what do we need to do a hump for the Should we do a hump for the general approach and then for the specific?
Yeah, I guess that's the first thing. Like, are people generally okay with like this like okay by which I mean willing to hold their noses and like move forward with this set of changes?
Okay, so if this is a question for the general approach of not specifically compatibility mode, but the other changes made to make it look more like a TLS 1.2 handshake. First, is there any people who want to get up and object to that?
Paul August. Does this work? Okay.
Yeah.
So, I would like to give everybody who worked on this like their beer back. This is insane. Like, why these middle boxes? They're meant to do either deep packet inspection to help you with your plain text or to somehow protect you. If these boxes are not getting updated for 1.3, they're dead in the water and they do nothing. So they will either need to be updated to support TLS 1.3 natively, or they need to be removed from the network. Meanwhile, if this breaks, you can just go back and suffer one round trip of latency to go back to TLS 1.2. Why are we hobbling TLS 1.3 for the next 15 years just to support these boxes that should have been removed or updated from the network anyway? Like, is latency that important?
It's not about latency. It's not about latency. It's about having insecure fallback. Is that basically now that means any person in the network can force you back to TLS 1.2 and you can't do anything about it.
Hi, Avniran. I don't have a middle box anymore, but when I used to have a middle box, I would never fix it if it worked. So if we make TLS 1.3 so that it works with existing middle boxes, they'll never get updated.
So I think my assumption here, and I'm purely speculating, but is there two kinds of middle boxes at play here. One are just basically ones that are doing non-deep packet inspection but doing state machine enforcement, and those guys, you're right, will never change. And the second is the set of people who are doing who are doing like decryption, right? And those people like are going to want to inspect 1.3, and they're going to change because they're just going to start losing traffic.
All right, so then let's take a hum now. So the first hum is for leaving compatibility mode out now. Do you support the changes that Ecker outlined on the first slide? So first we'll do yes, and then we'll do no. So hum if you support the changes that Ecker proposed on the first slide. Hum if you do not support those changes. Thanks. I think that there was overwhelming support for the first. Okay, so for now we're going to do the same thing for compatibility mode. Any additional? Okay, so please hum if you support the changes for compatibility mode.
What you want is please hum if you think it should be required, and please hum if you think it should not be required. Please hum if you think. Maybe the question is.
Okay, I have a question here. Are you asking about whether compatibility mode exists?
No.
As mandatory
The
at all?
question is should you only have compatibility mode, or should you allow implementations to not send the fake session ID and not send CSF?
That's your understanding, but I'm trying to get what's in Joe's head, because he said the first slide on the last one, which means that he could have narrowed that to not compatibility mode. So are we talking? Was the first hum for everything that was invariant in Ecker's slides, including compatibility mode?
Yeah. So I think that the basic things for compatibility mode were on the first slide, right?
Okay.
So
Well,
I agree with Ecker's restatement.
Okay, Ecker's restatement, fine, thank you. Then, as Ecker said, you should say, should we require it? Should we not require it? No. Compatibility mode.
So should we require that the client and the server both do the stuff that is on the compatibility mode slide all the time, as opposed to the server can do? Yeah, sure. Right. No, I mean, basically what would be in compatibility mode? The question is, would the client always send the fake session ID, or would the client only do it conditionally on its own choice? And would the server always send change after spec because the client always send the session ID, or would it only do it if the client sends the session ID? I'm sorry, that was intended to be exactly 2 clicks. Right?
Okay. Are we clear?
Does someone else want to try restating? I thought it was clear.
Maybe you also ask at the end whether the people actually understand the issue, because that's a very detailed issue that may require some thought. So I have my opinion, but I'm curious on how many people actually understand it. Maybe ask it.
Okay. So the first question is, should we require compatibility mode? Should we only have compatibility mode? And the other one is, should compatibility mode be?
Yeah, correct.
Are we ready? No.
I've got a problem because I think I have different answers for the client and the server.
So my assumption is the way what I propose this text looks like is this: that the client can add its options and a fake session ID or not. The client can add its options and change their respect messages or not, and the server must change their respect if the client sends it a session ID. That is what I propose this text say. That is call that option A, and call option B that the client must always send a fake session ID, the server must always echo it, and everyone must always send the change type specs. Good. So maybe just come for A or B.
So B is the must, then, right?
All the way down the line.
Okay, so we're going to start with the hum for option B, that you must always use compatibility. Please hum if you support option B. Okay, and then please hum if you support option A. And then please hum if you feel like you don't understand the issue. Okay. Thank you. Thanks.
Okay, next slide, or back to the feature. No, sorry, above that. That's no fun. You spoiled it. So people suggested that if you were in compatibility mode, you should require the client to enforce the cardinality of the CCS, or the server for that matter. I don't know why I say client, which is to say that both sides send CCS exactly once in the place they're supposed to send it, as opposed to like an infinite number of times or 0 or whatever. I guess I would be fine. I mean, different, but I would live with requiring you to send it exactly once. I think requiring you to enforce it is like crazy pants, and like will make the implementation much harder. And our implementation is like very simple in this, and it would be like a huge pain in the ass to count or ensure that it appears in the right place.
This is Daniel Gilmore. So I also think that requiring the client to receive it seems to pick a specific number is crazy. I want to know, does this bogus CCS get factored into the handshake hash?
No. It isn't even under encryption.
But so we have there's a hash of the running handshake.
Yeah, it's not a handshake message. It wasn't even the handshake hash in 1.2.
And so this is just bytes on the wire that everyone's gonna pretend didn't exist.
Exactly so.
Except for the middle boxes.
Yes.
We think they're very important.
They love it.
Totally convinced they're important.
So Martin Thompson, Ecker and I had a bit of a discussion about the enforcement of the CCS thing, and it is very unpleasant to enforce this because you have to have knowledge about all sorts of things, particularly in the 0RTT case, where it's going to arrive at a particular point in time where you're just not expecting something like that. The other thing to note is that when the CCS arrives, you're expecting to be receiving encrypted handshake messages. And so you're going to throw that away or drop the connection likely. It doesn't flow through the usual path. It flows through the error handling path on your record decryption. So
it doesn't actually have to. You could look at the type first.
Well, you can look at the type. And
that's what we did, but I mean, like, yeah.
It's unpleasant.
So what I propose this text say is that the server has to send it in the conditions I indicated previously, and otherwise we don't say anything.
Let's call that option A.
So I mean, does anybody object to that? Does anybody think we should enforce? Does anybody think we should like require counting? I think we can just call that. Okay, next slide. David. While David's getting up, I'll say, I thank you for doing these measurements, by the way. We have some measurements coming, but we had a little bit of a glitch where I screwed up some of the test code. So I have data which seems to suggest, I don't know what, I don't want to characterize what it says. This is crazy. But hopefully we'll have our own data relatively soon when I understand the problem.
Oh, it's a microphone. Okay. So apparently, like, you all already made a decision, so I actually have it easy. I don't have to convince you all with all these disgusting numbers. Oh, sorry. All right, this better? Next slide, I guess, because this has no content. Yeah, so back in February, we tried to deploy Draft 18, and we were really excited about it. And the one thing that did go well is nobody hates the TLS 1.3 client hello. Like, everything we did worked. The server hello didn't really work. Our numbers are even more horrifying than Ecker's. Yeah, that means a fallback, if even that. I would be laughed out of the room for suggesting we deploy that thing. We were really dismayed when we found those numbers. It turns out middle boxes are intolerant to the TLS 1.3 server hello. Never mind that this is actually, as Echo suggested, not, this is violating our protocol invariance. But so it goes. Next slide. Yeah, so we went and tried to figure out, get as much information on these middle boxes as we could, which turned out to be kind of difficult because, like, you have to get these people to talk to their IT people and so on. On a general rule, what we found is the TLS terminating middle boxes. This is sort of like these proxies that will, like, terminate the connection. They are a trusted CA, blah, blah, blah. They generally work fine because they're just a client and server connected back to back. If your server is implemented correctly, if your client is implemented correctly, then everything works out fine. Haha. There's some footnotes here. But there are a bunch of other middle boxes that are sometimes the same middle boxes in different configurations. Try to process TLS without terminating it. They do all kinds of random things. Sometimes they're just checking length prefixes because they thought that'd be fun. And yeah, as a result, they parse a whole bunch of version-specific messages, which is not, like, this violates all of our assumptions about how we change the protocol, and they break. Unfortunately, although they are not working correctly, that 92% was kind of a horrifying number. I don't think we can steamroll over that. This is an oversimplified picture. Like, we do break some of the TLS terminating middle boxes because they have some parts of their process that you could probably describe as a non-terminating middle box. This is sort of, they're weird. Next slide. So, I think it was like 95. Okay, so yeah, so given that draft 18 was not going to work, we went and tried some alternative options based on Kyle's suggestion. We tested, so we actually have some local configurations to test with based on some of the, like, information we got from our bug reporters. So we iterated locally where we could, but what we have locally is not even close to the, like, wide range of stuff we're seeing in the wild. So we had to run some tests in the wild. This unfortunately takes some time, which is why it's been like a year. So in our first round of experiments, we did not realize we had to make the record layer change, and resulted in that. PR 1051, if you remember, is the server plaintext content type proposal. So at least in our experiments, that's a no-go. Also, omitting the client session ID gives you an error rate of 95.4%. So that also doesn't seem to work. The experiment version seems to work, but there was some loss. And we had these confirmed by user reports. Their user reports are not a great metric because you get like 10 of them total. But thankfully, we got some for the experiment version. Next slide. So based on that, we managed to reduce it and change the record version, and that seems to work. It actually does better than TLS 1.2, but I suspect that's noise because these numbers are kind of fuzzy. We also tried to get some HP level metrics. So these are metrics for handshake. So the reason the baseline is higher than Ecker's is because we throw out the TCP level failures. So once we successfully connect TCP, then we check whether handshake succeeded. We also tried to get some HP level metrics. They were added late, so I'm not confident in whether or not they like measure what we're trying to measure. But they are consistent in that it doesn't explode. And it's been on beta for a few weeks now, and it was on our dev channel for a bit. And so far, no user reports. Around this time, the last round, we did have user reports. We'll see if this survives disable. I'm very optimistic. That is certainly a nice number. That's the end of my slide.
Yeah, no, I'm going to be YouTube. We're moving on.
David, thanks for doing the measurements, man.
Also, it wasn't just me, like other folks.
So this is Daniel Kahn-Gilmore. Thank you for doing these measurements and for reporting back. I confess that I
am uneasy about the unreproducibility of these experiments. So I appreciate that you have the resources to be able to pull this off. Most of the rest of us don't. And if we're making decisions on this basis, how are we going to know that they're borne out in experience? That shrug is what I'm feeling right now. And I'm sorry,
Yeah.
like, I appreciate that you did the work and that you brought it back here. That's awesome. But I don't know how we can responsibly decide to use this information or not use it to make decisions.
Honestly, I don't have a good answer. I mean, Ecker's going to do some experiments on the Mozilla side. Like, this is part of why the middle box problems are much more annoying than the endpoint problems. Because endpoint, I can just tell you, here's a URL, it's behaving weird.
Right.
Like, we couldn't do the experiments without, like, I mean, we have some local configurations, but they're not really sufficient. The local configuration said that, like, we didn't even need to send the client session.
Here's my take on this. I mean, we're going to run our own numbers, and like what's going to happen is people are going to start. I mean, so basically, we and Chrome and like basically in a hackathon, everybody got this in their versions, right? And so what we all supposed to do is roll out like to as far as we can down our channels to beta and release with draft 22, which is what's going to have this in it, and then we'll have direct user reports of failures if it fails. And then we'll have a little bit of time if it fails to like fall back. And because it'll be draft 22, it won't be 1.3. Like it won't be committing us permanently to these changes because it's totally screwed up. But I don't see another way to make the change. I mean, like the bottom line is with the field to find out, right? And so, like, I mean, David showed me this, showed me what they wanted to do, and I was like, kind of like vomiting. And but I mean, I'm persuaded. I mean, I can tell you the data we're seeing now isn't good enough without making these changes. It is not good enough. So, you know, this is what we got.
So I think we can all agree that the proposed workarounds are horrific.
Well,
and also that losing the large percentage of traffic is also horrific, right?
Yeah.
We're stuck with these like
well,
not so great choices.
I think they're just unaesthetic. I mean, at the end of the day, they're really just unaesthetic, right? At the end of the day, I mean, horrific would have been if we had changed the crypto. They're really, I mean, like, doesn't require any analysis. It's
Sorry,
just
can
unaesthetic.
you dial it back to 0.75
Oh,
acres?
sorry.
I'm not understanding.
I think they're just unaesthetic. At the end of the day, right? If we had to change the crypto, I'd be really worried. But this is formatting.
It's formatting, but it's complexity in the implementations, right? We've been bitten by implementation complexity in the past in TLS.
This is why I resisted required in the state machine.
So on the complexity side, at least our experience is by far the most painful part was just teaching our stack that there were now 6 different versions of TLS 1.3. The actual changes were not too bad, I think.
Commensurate code size for us.
Hi, Nick Sullivan, Cloudflare. We're committing to build a website. We have it sort of half made that allows you to very fast change changes in TLS versions so that it doesn't take an entire browser rollout to get the code into browsers and do these experiments. So there are ways of quickly updating the code. It doesn't go out to everybody. It's a selective group, but if someone is having problems, we can use a tool like this to debug.
Ben?
Hey there. So you say that you would be a lot more uneasy if there were changes to the crypto, but it's not entirely clear to me that you could actually characterize this as no changes to the crypto, because we now have these cipherspec messages that like everybody's ignoring, and they're interspersed among the crypto, and I feel a little bit uncomfortable about that, not a lot uncomfortable about that.
We also have an application data byte and like the record there version that is completely ignored and dispersed among the crypto.
Rich Sauls, Akamai, and OpenSSL. I share a little bit about Dan's concern about the non-reproducibility. I think a lesson to take away for the future is more transparency, more involvement with a wider group of people experimenting. I understand the trade-offs with that. Also, in terms of a lesson for the future, I agree with Ecker that this is just like
offending geek aesthetics, but we should explicitly document why this is happening, not naming names or shaming anyone. Perhaps not in a published formal document, right? Save that for bad attitude. But just so that in the future, when someone comes back next year and we start TLS next, TLS 2020, it will look, oh yeah, we had to do this back then because there was this problem with intermediaries.
So some of that's in the document, but more will be welcome if people want to.
Yeah, it needs more.
Okay. I can make correct that.
So in addition to the documentation, if we're talking about what this means for the future, I'm wondering if the folks who are building out these measurement infrastructures could commit in some way to having the measurement infrastructures be able to report when we can turn off the grossness.
We can at least. I mean, David thinks the answer is
I
no.
mean, I'm not asking you to make a commitment right now,
Yeah,
but like
no.
that would be. It's one thing. It's great to have this data in the design process, but if we're adding things that we know we want to get rid of eventually, it'd be great to have the folks who have that infrastructure be able to help us also get rid of them when we can.
I'm willing to commit to the entire package at the measurement.
Yeah, I'm skeptical and a little bit concerned about the black holing, but it might like we weren't actually measuring for this. It was just we saw some some like evidence which pointed to it. But I like if like we can experiment with doing some kind of like fallback thing.
Okay. Thanks. Thank you very much. Thanks, David. Really, by the way, like honestly, great work by the Chrome team and Necritz. That was like really nice. Okay, so okay, great. So now that we resolved like the difficult thing, this other stuff is like smooth sailing. We only have two minor trivial issues, both of which we have PRs for. Right now, the close notify in TLS 1.2 is like full close. Well, sort of full close. Basically, when you receive a close notify, you're required to flush or discard all your outstanding untransmitted data. But of course, it means you can't like recant the stuff you already sent, and you can't recant the stuff in the TCP buffers. So like what it presumably means is you like ditch whatever's in your application buffer that needs to be close notified. Like this is like kind of incoherent. Lots of implementations don't do this. I was looking, like, I don't think EquinSSL does. Apparently, I don't think Boring does. NSS doesn't. So it's kind of silly. No one, this goes back, this isn't like SSL version 3. No one knows why it's there. We're gonna have to do like, call Paul Kocher or like ask him or something. And it turns out that there are application reasons why people want to have close, because partly because they expect it from TCP, and partly because if you have a protocol which expects a fin bit to tell you things or to tell you what's done with its side, then sometimes you want to keep writing after that. So the proposal here in PR 1092 is to basically just remove the thing that says that you have to like flush all your data and allow you to keep sending, so it's a half close. This is nice thing is this is backward compatible with previous behavior because, as I said, it's unobservable the other side didn't comply with this requirement in the first place. And if you choose to, and of course you can always continue to comply with the requirement if you so choose. We had this discussion a while back, and I sort of like was kind of personally waved it off, but I've been persuaded now that I think this is the right answer. I guess one question that did come up by Hubert Cario was how you respond if you've already sent close notify and you get some sort of bogus packet, which I mean can still happen because which could always have happened because you could send close notify and the other guy's stuff could be in flight, and then do you send an alert or do you just like hang up the phone? Like I was probably going to leave this entirely like the rules don't prohibit doing this, and I just personally leave that entirely up to your discretion.
Yeah, Martin Thompson, I agree with that point. NSS actually does block writes after receiving a close notify. I checked.
Oh, does it? Okay.
But it's like a very small number of lines of code to remove that.
Well, and it would not be you would not be non-compliant if I continued to do that.
Well, we would remain compliant. It's just it would be inconvenient for people who wanted to do the sorts of things that David was talking about doing.
Yep.
I would make that change.
Okay.
After
so
this.
I'd like to anybody object to merging this PR? Okay, I'm gonna like merge this PR like when I sit down. It's already done. It's like just a button push. Okay, next slide. Okay, this is a little more hairy. So 6066 totally prohibits resuming with separate SNIs. So if you like negotiate with SNI 1 and you cannot like renegotiate, you cannot like try to resume SNI 2, and it also prohibits the server from accepting this. I don't quite have a survey, but I talked to people. My understanding is implementation is like extraordinarily inconsistent about actually enforcing this rule. I think people may be okay. I think so in particular, like if you have like an internal session cache, like probably you don't like probably you don't accidentally try to resume with the wrong SNI. But the servers aren't good about enforcing SNI non-resumption. Though I think NSS actually is. But I think boring on how it is. I think Open does not. Victor posted this PR in 1080, Victor Vasiliev, suggesting basically slightly relaxing these requirements to make them look a little more like HTTP connection coalescence. Namely, that the client is still required to only resume if the SNI is in the certificate, but if the certificate had multiple subject alt names, it could like resume with any of them. But it should only resume if the SNI is the same, because the reason is the server like probably isn't going to let you do that anyway if you change it. The intention here is we've opened the door for the server to have some other extension later where it said, like, listen, I could allow you to cross resume anytime you want. One thing I don't think is in Victor's PR is a requirement that the server must check that the SNI is in the certificate, but we probably should have that too. From my perspective, I'm a little uneasy about this, but I think it's probably the right answer. I'm uneasy about it because we have seen problems with SNI management. There's a nice paper by Antoine Delano-Leveau and some other people about SNI mismanagement and session caches. But those are defective in 1.2. But the situation, but most of those things actually turn out to be situations where you get inconsistencies between like the SNI and the HTTP host header and stuff like that. And it turns out that like we already have all those problems with the HTTP connection coalescence. We've already basically decided that like we're gonna treat all the sands in the certificate as if they were part of the connection state. So like, and I always hate taking something out which kind of feels like a security concern. So I guess I'm not going to strongly advocate for this. If I had to like actually like, I'm kind of like, yeah. If I had to like decide one way or the other, I'd probably go for it. But I'm not. I think I'm really taking. I'm not going to make a recommendation to disagree with it.
Yeah, Martin Thompson, I'm going to argue for taking it simply on the grounds that we've basically already taken on the risks, and it really does still say, don't change the SNI. It's just that we've cracked the door.
Yeah,
and I think it'd be foolish at this point to do anything other than send the SNI, the exact same SNI as before, because stuff happens.
I mean, we could if we wanted, say, must not unless there's some external reason to think it's okay.
That would be
preferable
to me.
That would make room for the door, but not actually open it.
Yeah.
Unlock it.
Yeah.
So I think
unlock the door.
So I think that's probably. Oh, here's Victor. So I can.
Must
he
not
can
unless.
advocate for this. I don't have to.
Can you hear me? Okay, so the reason I believe this is reasonable is we currently support if you're connected to foo.example.com and it shares IP with bar.example.com and you have a wildcard for star.example.com, then you can HTTP connection pool. But if you connect to foo.example.com, you cannot later resume and zero RTT to bar.example.com. And there isn't security-wise any reason to do this. So the PR lifts the strict requirement from RFC 6066. It still discourages implementation from always cross-resuming, and there are two reasons for this. One, you don't necessarily know that like all domains served within the same cert actually share the session key, the session ticket encryption key. And wasting one-time tickets is suboptimal in terms of performance. And two, there are some implementations which might not be ready and get in some ways confused. As Acker mentioned, there were multiple bugs in implementations where they did not quite realize what was going on. So the premise is, originally I wrote a PR which added an extension to new session ticket, which allowed you to do this. And Acker told me to bring it in a separate draft, and I will later bring in separate draft if the working group agrees that in general this restriction is unnecessary. I have a draft to actually negotiate cross resumption. So this is mostly opt-in, and this is mostly, the PR is mostly agreeing that this is crypto security wise safe to do. And it's only implementation issues which are preventing us from doing that.
Kyle Necritz. I mostly agree with Victor. I think we're basically in a situation where some implementations use SNI for different things. Some basically use it as a way to select the certificate, and other use cases will actually go and verify it further. When you're just using it to select a certificate, if a slightly different SNI value would use cause you to select the same certificate, then you're going to do the exact same thing with like HTTP2 connection coalescing. It seems silly to forbid resuming the session, but then just resume to a different SNI and send connections to the same place. So I think like if we don't merge this PR, we're going to basically end up in the same place we're at right now, where it says you must not do this in a spec, but some implementations routinely ignore that because there's really not an actual reason in all cases.
David, you sure, David?
Ted Hardy, I think I'm confused about something, and I hope you can disabuse me of this confusion relatively quickly. So walking through this, what I imagine happening is I go to foo.example.net. It gives me a set of other subject alt names in the certificate. I may or may not have any interaction with those names. I get my new session ticket, I go away, and I wish to come back and go to bar.example.net instead of foo.example.net. It's not clear to me in this case why I don't make an initial request to foo.example.net, confirm that I get the same subject alt names back, and then proceed talking to bar. Is the reason latency? Is the reason I don't want to make a request to foo.example.net because they're not all idempotent? Or is something else going on?
I mean, Victor can answer this, but I think it's latency and that the browser stack doesn't want to do that, right? That basically that when you come down from the point where you're making the TLS connection, like you've already decided what HTTP you're going to do.
Okay.
But Victor may have a different opinion, but that's my impression.
I'm not sure I quite understand the question. So the reason is that you're trying to connect to foo.example.com, and then you talk to bar.example.com, but you don't have an existing connection to foo. And connecting to bar is strictly faster than connecting to foo and then trying to talk to bar later.
So I thoroughly agree with you that it's faster if you can do this cross-subject alt name resumption. But it certainly seems like it would work in the other case if you had some query you're willing to do to foo that was known to be idempotent.
You wouldn't need a query. What you'd do is you'd SNI. You'd basically send. I mean, if you wanted to do what you're suggesting, you would send foo's SNI.
Right.
Then you would look at the certificate you got back. If it contained bar, you would continue. If it didn't, you would turn it down and get. So you wouldn't have to worry outside of that. It's a latency issue.
Yeah, I agree. It's a latency issue. I just wondered whether it was just latency or there was some other mechanical problem.
I think it's just latency and some level of implementation inconvenience. I mean, like, okay. Implementation convenience resolve the problem by basically doing, you feed in bar. We do the lookup. We find the certificate that had foo and bar in it. We look at the SNI we used the first time, and then we just throw the SNI out and put a new one in, and then we look at the origin and say, is it okay or not? But that means the RTT won't work, and it means you lost a run check, right?
Okay, that was the point I wanted clarification on. I appreciate it. Thank you.
Ian Sweat, Google. I just want to say that I definitely support doing this for the reasons Victor said, and Victor did a really nice job summarizing, so I don't really need to say much more. But one added note about the two host names is they may or may not be able to actually serve you the same content. So it's not like, oh, I could just like connect to that one and then connection pool or do something. Like they might actually, it is for latency, but like they may be physically destroying the session.
But wait a second. I mean,
Even if they share
so,
the
so,
same
so,
server.
okay, so you're saying to the case where basically you're saying you might have foo and bar, and they share a session ticket encryption key.
Yep.
So they can cross resume, but then they send different things in the back end. And so now, I mean, like, and so if you get the wrong SNI, then you end up basically talking, like basically connected to the wrong.
Who's gonna? Yeah,
wrong
they're
front end
basically gonna
instance.
like redirect you or do something.
Right. And so I mean, I guess I see that how you could do that. But let me point out, this is exactly the this type of configurations that got people in trouble with SNI and session resumption confusion in the beginning, right? Exactly keying your behavior, the behavior of like which server you send to on the SNI, and having those be different, and having them share a session cache is exactly how you get in trouble. Like if you look at the host header, it's cool, but if you like say you basically assume that like the it's a little complicated, I guess is what I'd say.
Well, so I think what Ian trying to point out is you can have foo1 and foo2.example.com, and they might be like physically different IPs, but they share the same ticket key.
Yeah.
So
No,
it's kind of like connection pooling, except it's kind of more powerful than connection pooling in sense that IP can differ, but they're still cryptographically the same machine.
No, I agree. I'm just saying that if you have a situation in which you have sometimes you have the SNI, sometimes some parts of the state overlap and some parts of the state don't. That's like how you get confusion. I don't know how to mount an attack here. I'm just saying, like, if you go back and you read the paper by Dylan Laveau and others, they were like basically taking advantage of confusion about routing.
Piotr Sikora, Google. I'm generally in support for cross SNI session resumption. However, it's not clear to me that just the fact that you share the certificate would lead to the same virtual host. And in that case, you would be sending early data on session resumption that's not destined to the host you are sending, which is wasteful.
This is why Victor says you shouldn't do this unless someone tells you otherwise. And I agree, it's fine if someone tells you otherwise.
David Benjamin. So on the confusion side, I think it's actually less dire than you're suggesting.
I didn't mean to say it was that dire. I'm sorry.
Okay. So if your protocol, so like whether or not you look at like something like the host header or the SNI is like largely a function of the protocol. In H2, we have like very solidly said you look at hosts and not SNI because otherwise cross-chain pooling wouldn't work. In H1, it might be a little bit fuzzier. But suppose I were to cross-resume a foo.com session with bar.com. The SNI that I send is still bar.com. And so if the server were to look at the SNI, it still says bar.com. Now, there's a slight subtlety here, which is the SNI is ambiguous in that you might believe SNI is a connection level routing thing, in which case it is not part of session state. Or you might believe SNI is like some negotiated property of the session and that when you resume, you like use the same one. If you believe in the first interpretation where it's a per connection thing, then like cross resumption is just like, this is a ball of crypto, like either it worked or it didn't work. But like this is a key, either you have, this is a PSK, either you have the PSK or you didn't have the PSK. If you believe that it is a per session property, then now you open the door to this confusion where the get server name API in your like library returns foo when the outer one was bar. In that case, I would say that like, so I think we should merge this PR, but there's one subtle consequence of it, which is if you believe it is per session state, you must implement RFC 6066's rules. Otherwise, you will get confused.
Do you think you could send a amendment to the
Yeah,
PR?
I can add that. Like there is already a must in there. It's just that like some implementations ignore it. So we ignore it because I'm expecting that Victor will come down and ask us for it pretty soon. But in preparation for that, we removed all per session SNI state. There are some implementations which both ignore it and have per session SNI state, and that combination is not a good one.
What do people think? I guess we've had some discussion. I haven't heard anybody really against this. As I said, I'm waffling. Do you want to take a home?
Does anybody object to adopting this PR?
I know Antoine did on the GitHub, but he's the only person I think. I will do it as directed by the chairs, whatever it is.
Yeah, we should merge it.
Okay, so I'll wait for David to send me a PR against the PR, and then I'll merge the whole thing. Okay, next slide. Right. So where are we? I'm gonna merge these PRs. Issue 22, like El Pronto. It won't be this week, but hopefully it'll be like Monday. I could be this week if I like actually get fancy enough in 1091. Then I propose issue 22. I'm issue 22, and then like I leave the mechanics to you. What we should do. Do you want to do? I mean, what do you want to?
It will be a targeted working group last call. There's no doubt about
Okay.
that. I guess I just want to make sure that do you have any feeling for when you might be able to get your test data?
So this is in beta now. Like the thing is in beta now. I've got to like write the experiment to actually test it, which I'm going to do like basically next week, and I'm hoping to have data in the next, I would say. I mean, the optimistic version, we're going to have data by the end of the month. The pessimistic version, I have data by this time next month. You disagree, Martin?
Yeah, I suspect we can have something a bit sooner than that. I mean, we landed the code for this, the current botched experiment on what, Friday?
Saturday.
Yeah, and you were giving me murmurings about weird numbers on Tuesday, so it shouldn't take too long.
Yeah, so I mean, there's some possibility I can have it. Depending on if I have to patch Firefox. That's the thing I'm concerned about.
So what I'm concerned about, right, is that, you know, the numbers that we got from Google, I think, are great. I think that to be responsible, we have to make sure we have another data point. That's all I'm saying. So when we can actually get that data to show that's basically in the same kind of range, I don't want to argue about the 0.2% or whatever. Then we can go ahead and work.
So why don't we do this? I'll commit to reporting back to the working group end of next week on where I am about where I am at having the data, and maybe I'll have it, or maybe I'll have it real soon, and I'll report back, and then you can modulate your working class calls based on that. But I'll issue 22 right away.
Yeah, no. So that's my theory: is get 22 out. My assumption is that the data is going to show the same thing, and then we'll wait to actually issue the official class call until you get back to the data. That'd be great.
So Sean, you're saying you want to wait for his results before you issue working group last call, or would you consider the feedback from the experiment as just another working group last call comment?
We could do that. I mean, my assumption is that there's no reason why the Google numbers would be tweaked in a certain way, right? They are what they are. I've
seen no evidence to suggest
right.
that we
So
produce any different results.
So my theory basically is that I could live with that, where we could do a working group last call and wait. So the minute you pump out 22, we can hit the button. I mean, it's 2 weeks. It still have to go through an IETF last call, so it's not the end of the world, right? If we do figure something out, yada yada yada.
Yeah.
But,
So I'll point out that we basically discussed all of the changes, the technical changes, just about to in draft 22 right here, right now. So this slide deck is pretty much the working group last call contents. I think there's like a few other tweaky things, but most of them.
I moved I moved the client server certificate type into E8. The other thing I did, as we discussed last time.
Yeah.
Okay. Well, I'm gonna let you manage this.
No. So I think that's that's our plan. So that we'll go ahead and you pump it out. We'll do the working group last call. We'll obviously put something in the working group last call about verifying the data.
I guess one thing. I mean, David, how far away are you from having 22 in a deployed version? Because that's actually you may be slower than us. I don't know.
You mean a deployed version on like running code, or like we just need to change 2 numbers because we called it 7004.
I mean, can you have it in GFE?
Oh, in the GFE, that might take. I'm not sure exactly the timeline, but maybe like order of a week or 2.
So basically, there are 2 experiments you can do. We can do basically their experiment with trivial modifications, or we can do 22. I can get. I mean, obviously, like the latency for 22 is like how long it takes us to get it into Firefox and Chrome, which is going to be a couple more days at least.
Yeah. Oh, actually, it occurs to me there's. I'm going to need to talk to the server people and then I'll get back to you.
We will report back ASAP with what we plan to do.
Absolutely.
But at least we can definitely do an experiment. And the way our stuff works, I can test against anybody's server. So if someone else wants to stand up another set of server farms, I can test against them too. And I'm happy to publish the code we're doing this. So like it's really just a matter of like I need to be able to for Firefox to be able to connect against some servers that are configured with one of these experiments.
We can certainly so if you end up picking our like random fake one, Like when we go and switch it to 22, the random fake one will still be there. The question is, I'm not sure exactly when 22 will show up.
Okay.
It might be order of a week, or like a few weeks.
Okay, so
I
let's
need to check.
we will report back to the list like either soon, either like this week or mid next week. What experience exactly we're going to do.
We should be able to have something with 22 in a couple days.
Actually, that'd be fantastic because then we wouldn't then Gmail would be out of the picture, and this would be much more like the data we've already done. So in that case, we'll do 22, yeah.
Rick Sauce, so is the plan to do a last call after 22 comes out? Another one?
Yes. So the working group last, obviously, we're going to confirm. We're going to kind of
Yeah.
do things, two things at once, and confirm on the list that these changes are good. But we can do that.
So I'd like to. I think after we get confirmation of Google's numbers, then do the last call. It's not going to materially affect anything, even if you make it just 1 week. It looks better. It feels better.
Me. Actually, Martin, I just realized you have to talk because we'll have to uplift 22 then. We want that. Okay. But if so go ahead, Nick.
As long as 22 lands in boring SSL, we should probably be able to get it for Cloudflare in the next 2 weeks as well.
Fantastic, because like the vast majority of our like R13 is like Cloudflare and Gmail. So if we had, I don't want to take a huge 1.3 regression in our numbers, but okay, great. So we'll work on that. Okay, that's it for TLS 1.3. I'm going to deal with details 1.3.
Details 1.3 is up next.
Any chance I can have that bottle of water? Okay. Thank you, everybody. Okay, this is joint work with Hannes and Nagendra. Nagendra was like last minute, couldn't make it. Hannes is over there. There are a modest number of changes since 01. I did this short record header thing, which I'm going to talk about. I'm going to talk about each of these things. Short record headers. I basically made it clear you could do an empty ACK, which you sometimes need in cases where you're receiving, like, say you receive the server's encrypted extensions, but you don't receive the server hello, like you'd like to be able to shortcut the round trip time. And I reintroduced key updates because now that you have ACKs, the key update works really well. Next slide. So we had a long discussion about how to make this record header short back in Prague, and I sort of took home that like we hadn't really managed to optimize as well as we could. And Martin and I went back and workshopped it a bit, and so we figured out how to improve things quite a bit, I think. Basically, the idea is that there are actually two new header formats, one of which is basically just a trimmed down version of the original header format, and one of which is like actually like super compressed. And the point and the key difference between them is, do they have a length field, and so can you pack more than one in a record, more than one in a UDP datagram. And so this is the first one, which is basically just like the existing record format, except that like I took 64 bits and crammed it down to 32, and I did that by basically making the sequence number 30 bits long and the epoch 2 bits long, and otherwise is exactly like the current format.
So Martin Thompson, I realize I haven't asked you this question before. Is the reason that the sequence number is much longer in this form because you want a larger sequence number space? Is this your fallback?
Yeah, that's why, basically, because it's either out of RNs.
Yeah.
And because I conclude, yeah, exactly. This is just like wherever you use details 1.2 text, you use this. And because you do version negotiation first, you know exactly what you're getting by the time you see this value. So it's very straightforward. Next slide. Now the fancy one is, this is basically Martin's, which is basically a you take the epoch in the sequence and you pack them into a single into a single 2-byte word, with the epoch being 1 bit and the sequence being the remaining 12. This has some restrictions, which is why it's not the basic format. First of all, you can only use it with one RTT data because the epoch bit is too short to let you basically determine which of the multiple epochs that are in play during 0RTT work. That's part of why the other one's got 2 bits instead of 1. And the other is that you can only use it when you have one record bracket because there's no length, so you can't figure out how long the value is. But it's 2-byte overhead, so it's much better. And by the way, like, if you work it out, you can demux. There's a rule for how to demux, but basically the bottom line is that no matter what, because these values always fall in the 32 to 63 range, and the content type otherwise application, you can always figure out which one it is. So it works fine.
Yeah, Martin Thompson, the draft that talks about demarcs puts turn channels, I think. Oh no, this is it. This is the turn channels are separate to this, aren't they?
Yeah. No,
Yeah.
this is already
fits in the DTLS.
This is already
range.
the safety TLS range. That's thanks to you. David.
So I think this is fine, but you did mention that you know what you're expecting because you've picked the version at this point. Is that actually true if the server hello got reordered with an encrypted packet?
Well, you can't process that anyway, right?
Right, but you want to drop it on the floor cleanly and not accidentally think it is a server hello and be like, well, this was a garbage server hello. I'm going to break the connection now.
Oh no, you won't think it's garbage server low. It also can't conflict with server low. You know that this is
right because you set the high bit or something.
Is at bit number 3. So
the point here is that server hello will be 22, and all the other encrypted stuff will be 23, and this will be between 32 and 63.
Yeah, right. Okay. Next slide. So you need to so the one thing you'll notice is we used to be we used long ass values and they couldn't overflow, and so you didn't have things were simple. If you want to use short values, you have to deal with bit values being short, and so basically you need to be able to reconstruct the sequence number in the epoch from just the residue at the bottom. We're using the same algorithms as Quick uses, basically, which is the next sequence number. Basically what you do is you know the right hand side of the sequence number, and then the left hand side is uncertain to within basically, it could be one up or one down effectively of what the previous left hand side you perceived. And so what you do is you basically use the full sequence number that would get you closest to the thing you expected to receive next. So that works fine. That's what it does. The epoch, basically what you do is if the lower bits of the epoch match, you just decrypt right away. If the higher bits of the epoch match that lower bits of the epoch don't match, then basically you reconstruct the epoch for the next one up or the next one down, and then you look to see which sequence number will get you closest, and you take that. Actually, Martin's going to say in a second that you won't actually have to deal with this as badly if you take the key update patch that he wants. So, so this is a pretty simple rules. We don't have this implemented, but we think it'll work fine. And they've had the first one implementing quick because we already did the first one. Next slide. Right. Can you go forward one more? Oh my God. Okay. So right. So I pulled key update back. We had taken it out because we were doing anticipatory. We were looking at the epoch bit and going, oh, we'll go forward. But now you don't need that. And we're trying to avoid trial decryption. So basically, I pulled the key update back in, and right now we're just like TLS 1.3, which is you send the key update, and you change keys right away, and then you have a update requested or update not requested bit, and the other side has to respond, and the reliability is papered over by having the axe in the normal way. That's the way it currently is. Martin persuaded me after a conversation that I'd originally been right when I complained about this before, and I was wrong now, which is that it's not a good idea to start sending right away, because if you have reordering, then basically the receiver has some complicated algorithms for managing it. You have to do trial decryption, which is gross, or you have to start the packet, which well, eventually things will succeed, will not be great. So Martin's suggestion was that unlike TLS 1.3, you can't change the new key until you've received the key update's acknowledgement, because then you know the other side's ready for it. And then if you do that, then the other side also won't have to worry. And if you couple that with a rule that says you can only have one key update in flight, which you already have, the other side will unambiguously be able to determine which epoch things are from, and they won't have to do any nonsense that just reconstructs the sequence number in the usual way. So I was sort of back and forth on this, but I concluded this is the right answer. So I'm going to propose to change the document to say that instead of this, if what it currently says. The only sort of annoying bit is it's different than the TLS 1.3 rule, but that's not hard to implement because you have to keep the state around for the retransmit timer anyway.
Yeah. So Martin Thompson had a poke at trying to implement this and ran into problems with timers. So it's not necessarily perfect because in the test that I was running, I still had the handshake related timers running, and overlapping those with trying to do a key update was a little tricky.
Well, that'll be true either way, right?
That's going to be true either way. I think that's just sitting down and thinking it through and working it out. I spent 10 minutes on it.
Yeah, I think, I mean, the bottom line is details only do have one timer, and this has more timers.
Right. This should work fine.
Yeah, I think it will as well.
Is my expectation.
I'm going to make this change unless anybody objects. And then also simplify that bucket construction. Okay. Back one more slide. Right. So this is like, I think should be non-controversial. There are cases where you can't decrypt part of the flight. So say you get SH, say SH and EE are sent, right? And for some reason the EE comes in first. So you're just like sitting on this thing. You know it's encrypted. You got the F5 bits. You know what it's from, but you can't do anything with it because you don't have like the keys you need to decrypt it, right? So and now in like in DTLS 1.2, you would just like, I don't know, drop it on the floor or buffer it or whatever, and like eventually the other guy would like retransmit the server hello and you'd be fine, right? But part of the point of like the ACK stuff we're doing in DTLS 1.3 is like avoid having retransmit timeouts basically for like things when you're getting partial messages. And so this is one case where we can't easily recover. And so right now, sorry, in what version 2, or what previous version, whatever it was, this case just fell back to the retransmit timer. But what I changed this time is you can say, is in this case you said an empty ACK, which is now permitted because like it's just a matter of changing the floor to like 0 instead of 1. And then the other side doesn't need to change its logic at all. The other side's logic is the same logic, which is whenever you get an ACK, basically, if you haven't retransmitted recently, you retransmit right away with everything you're missing. And so this causes the other side to retransmit the whole flight. There's no way around that because you can't partially ACK things you have encrypted, otherwise you get deadlock. So this shortcuts the retransmit timer, so it's better than nothing. And it's basically the only thing you can do in these cases. And given the retransmit timers are quite long, it's actually a pretty big optimization.
So Martin Thompson, there's one thing that just thinking about this one. There is a possibility that the other side didn't pick TLS 1.3 when you received that message. And that's probably only in the case where there's a clear text message coming back.
You mean he's sending you?
So,
no, because there's no.
The client could send the second half of its client hello potentially, or
so I don't. So okay, let's work this through.
Yeah.
From when it's the client when you're applying this rule on the client, there's no problem because there's no way to get EE. There's no way to get EE without already knowing your 1.3 map basically.
There's no way of getting an encrypted packet, period.
Yeah, exactly. Basically, right.
Yeah. But if it's a clear text packet that say the second half of the server hello, which would be a bit weird because
but that you should acknowledge.
Even if you don't have.
Oh yeah, so right. So you're right. You can't until you know you're doing 1.3, you can't send acknowledgments at all.
Right.
You should be a little careful about that. Yes. But I think that's almost never going to be the case.
Almost never.
Yeah.
There's a few corner cases that we're going to have to be a little bit careful about.
Yeah.
Particularly when pieces of client hellos come in and when pieces of server hellos come in. But otherwise, mostly the rule will simply be if it's encrypted, you can.
Right. But that's true. That's true even without the empty ACK problem, right? Yeah. Ordinarily, if you got second half of the server hello, you would think to ACK it anyway, right?
Right.
Okay. Next slide. So that was the only open issue, literally, was this key update thing. So I proposed to issue the next version, and absent complaining, to get this working the last call, basically at the same time as TLS 1.3.
So all along, we knew that the DTLS spec would come pretty quickly after the 1.3. The TLS spec got done. So I'm kind of happy with this, and it'd be great if we can actually get them both at the door at the same time.
I mean, I think I think there are fewer implementers for this. I mean, eventually there will be a substantial number, but right now it's basically us. And I think ARM. So if you wanted to wait for us to have interrupt with ARM, that'd be okay. But I don't know how far along you are, Hannes. Are you pretty close?
Hannes was just complaining to me about how difficult this draft 22 change is going to be to implement. So I expect that's going to take a little while for those guys to do. I too would like to see at least 2 people talking to each other.
Okay.
It doesn't matter whether it's us and them or us and someone else. But
well, maybe us and Mint.
That would be fine too.
Okay. So if you want to wait, until we have a
just proof that we're not completely insane.
Okay.
Should only take a couple of months.
So because we're here, does anybody have any other issues that they know about that they want to bring up?
Okay.
All right, great. We're going to move on to connection ID.
Hannes.
Sean, doing a working group last call on this one, I think it would be useful because it would encourage the others to also take a very close look at it, like it happened with TLS as well.
So, I mean, so again, right, it's a working group last call. It might be the working group last call, but I'm actually okay with just doing the working group last call now. Like once it's on the less version, the
Okay.
changes incorporated. So I'm happy with that. I mean, we can make it longer if you want or something like that. But usually 2 weeks is fine. And there's still an IETF last call. Yada, yada, yada.
I just want to make sure that we don't go to publication without
I agree.
having two interoperating implementations.
I,
That would be
I think that really, because that helps us get through the ISG, right? It's like, okay, this does work. We do have two sets of people that aren't creating.
Okay.
Yeah.
Sounds good. Okay, last thing I want to talk about, and then I'm going to sit down, is the connection ID stuff. So this is actually a personal draft, but I'm hoping at the end of this, I'm going to ask for working acceptance. So this is joint work with Hannes, Thomas, and Tobias. This, unlike everything else we're talking about, is not entirely baked, though it is not entirely unbaked either. Next slide. So this is like recap from Frog. Initially, like the same basic crap was in DTLS 1.3, and people I think were kind of sad because they felt like it wasn't quite as finished, perhaps, and like also perhaps they felt like the privacy properties weren't as like awesome as they were hoping for, and that writing it in the details main spec might not be a great idea. So mostly what I just did, we like took the same stuff that I was proposing to do and like took it out and put it in like and put it in a different draft. So next slide. So the basic idea is like really straightforward. There's an extension that basically says, here is the ID that I would like you to use when you send to me. And then and it's like typical extension negotiation. And then once you've done that, then you send with the extension the other side gave you. And as usual, if the client like wants to like use the server's ID but doesn't want to send his own, then he sends an empty ID to elicit the ID from the other side. Because that's the way negotiation works. And so you can always say, I have like a zero length ID, which is what you do if you like if you want to receive, if you want to send with one but not receive with one. The important, they're not framed on the wire. And this is going to be a point of like some controversy in a minute. So just FYI. Next slide. So I didn't even write up like the negotiation. I have it in a document, but I'm not going to do it here because it's like so obvious. This is what the wire format looks like. Oh, by the way, this is also for 1.2. People wanted that. So like it goes in the sequence number and length on the wire and exactly the place you think it does. Martin.
Yeah, I just had a crazy thought. Can we reorder the connection ID and the length? Because I would like the connection ID to be indistinguishable from ciphertext.
Let's hold off on that for a second because there's other framing issues people want to talk about. Sure. Next slide. So 1.3, I didn't manage to put this in the draft because due to I plead incompetence, but it's pretty obvious. So here's what it would look like. So the draft contains like the old DTLS 1.3 ciphertext instructions that are the new ones, but it's like goes in the same place. It goes before the length, and when there's no length, it goes before like the non-length with ciphertext. So it's like pretty obvious. Next slide. So one thing that people noted was that like this got a privacy problem and you don't want to like have the same connection ID like in perpetuity. And as I think I mentioned repeatedly, like much to sort of my personal embarrassment, I've just spending like a crap ton of time trying to figure out how to like do, privacy preserving connection IDs. Like I gave up and concluded that I didn't know how to do them. And that the best thing we had to do was like give people, an opportunity to say, here is like a new connection ID, please use this one. And since they're delivered under encryption, like maybe if you like knew you were changing your IP address, you could change IDs. Like, and I freely admit this is like not good. I hacked this thing up, and it looks like this, which is basically there's a message called new connection ID, and it says, please now use this connection ID. Like here's a new connection ID you could use, and it has two semantics that are indicated by this like enum. The semantics are either throw away all your existing connection IDs and use this one now, or here's one you might want to use in the future if you felt like it. So just when we had lunch yesterday, there was some confusion about this. So I'll try to walk through it in a minute. The idea is that I might want to give you 5 connection IDs in case you want to change, because I know you're going to change IP addresses, but I don't know when. So what I do in that case is I give you one in the start of the connection, and I give you 4 more with the spare marking here, and that means just add them to your pool. And then and then say say my connection IDs, like I'm using self-encrypted connection IDs, and so I decide to roll over my connection ID ticket, right? My connection ID encryption key. Then what I want to do is I want you to flush and stop using all the old ones, like I'm throwing away the key, right? And so then I send you like one connection ID with like the immediate bit set, which is like throw away all the other ones, and then I send you 4 more with the spare bit set. So like this is not like ideal. And like I'm starting to think as I was having lunch with people that maybe it'd be better to make this an array in here, and then you wouldn't have to sort of send a pile of them. Because then you would have to like sort the message numbers. You still have to sort them a little bit, by the way, because otherwise multiple things might come in. But I'm not like sure this is the best mechanism, so I'm not friendly amendments will be accepted.
Yeah, Martin Thompson, I think the potential for having to sort by message ID is gross.
We have to do it anyway because the immediate bit means.
Oh right, yes, of course you have to because you have. Yeah, all right.
So I don't know. Again, like I guess my view of the state of this document is I'm going to, as I said at the end of this, ask for working acceptance, and one of the things I'm going to ask for, and I assume people are going to want to screw with some of the mechanisms here. So I'm presenting this, but I'm not like saying this like a final form thing.
Yeah, I think we can iterate on this. This is just
it's just
rearranging the bits around.
Exactly. Okay, next slide. Right. So there's a bunch of open issues people raised in privately on the list. But the biggest one is, do we need a way to tell if a connection ID is present? As the idea here is you might have a server which will allow you to use which would like you to use a connection ID, but doesn't enforce it. And so now you might be getting messages like from clients which didn't know about connection ID and clients which did, and now you have to figure out which ones it is. And like, I assert you can do this with some hackiness, but I think the people I talk to are kind of sad about it. So I know my co-authors are going to want to talk about this topic, though I propose you don't talk about this topic until after we've decided whether to accept the draft or not, because there's no point in like iterating on it if we just hate the whole concept. The second topic that came up, actually, all these things basically I propose we like defer to after we decide if we want to accept or not. The second thing that came up was, do we need to allow connection ID update for TLS 1.2? And I know, like I've sort of been taking the attitude that I'm working on 1.3 and I don't care about 1.2, but I know other people don't feel that way, so we may have to sort of like live with that. The last point that came up, and this is, I'm sort of embarrassed to say that I knew about this because I worked on it for Quick, but somehow forgot it when I did this work, is that if you just like have the record sequence number advancing one at a time, you get cross connection ID leakage. And so you need to change that. You need to like basically re-randomize the sequence number when you start sending. Technically speaking, you could just re-randomize unilaterally when you changed. That is not, however, ideal because it screws up the anti-replay mechanisms. Because when you get a new message, so you get a new CID, you know you know that the sequence number has been re-randomized. But the question is, where's the left edge of the replay window? And you don't know because you just got something like maybe in the middle of maybe in the middle of a flight, right? And so it'd be nice to be able to compute where the next edge of the replay window is. That the good news is we have this technique in Quick where basically you just essentially basically at the beginning of the connection you just establish a shared key that you use for basically to compute the gaps between the connection ID sequence numbers, and we can just hoist that right into here. So as I said, I'm sort of embarrassed because like I think I designed that and I somehow forgot about it. So these are all pretty modest. None of these are existential for like the existence of this document or not. So next slide. So I guess like my question is, are there any existential issues with this document that would stop us from adopting it? If so, I'd like to hear about them. And if not, I'd like to ask for adoption.
Okay, anybody have any issues? Yeah, how many people have read the document? Okay. Yeah, okay. Thanks. Anybody have any issues that they want to bring up now that adopting the document?
Tobias Gondrom, Huawei. So not an issue with adopting. I would have an issue if you wouldn't adopt it. And that is, I have literally millions of IoT devices out there that have trouble behind an app.
Okay.
So this is a very live, real issue at this moment, and I hope we can fix it somehow. Thank you.
Okay, anybody object to adopting this document? Yeah, sure. We're going to do a hum. If you are in favor of this adopting this if you are in favor of adopting this document, please hum. If you are not in favor of adopting this document, please hum.
Okay. Do we have time to cover the one open issue that I wanted to talk about, or shall I get off the stage? Okay. Hold on. Can I just show you the next slides if you'll know what I want to talk about? Right. Think about this on a resident list real soon. Oh, yeah.
We're going to adopt the document. I'll put the approval in so it's ready to go. All right, Nick, you're up.
Hello, I'm going to talk today about exported authenticators. Next slide, please. So TLS exported authenticators is a draft that's meant to solve a specific problem, which is that some application layer protocols, they need additional certificates, whether it's from the client side, post-handshake authentication in TLS 1.3 is a little bit awkward and optional, and perhaps in some scenarios, given a TLS connection, you might want additional server certificates. Next slide, please. Exported authenticators is a way to allow TLS library to export a piece of data that allows you to bind an additional certificate to the existing connection. And this can be done on the client side or the server side. The structure of this blob is defined in the document. It looks very much like a server hello series of messages: certificate, certificate verified, and finish. Next slide, please. This was proposed at IETF 96, adopted at 98, and we've had implementation since then that have worked. Since IETF 99, we've had some small minor cosmetic changes to the draft. At the last IETF, we discussed this, and the discussion was that this perhaps needed some academic review or some sort of formal analysis before moving to last call. Next, please. So in the meantime, Cass Kramers and Jonathan Hoyland from Oxford have created a preliminary Tamarin model to prove the security of export authenticators in the context of HTTP2 additional certs. There's some promising results for this. Next slide, please. But in recent discussions, there is a little bit of duplicated logic or undefined logic in the draft. Right now, as written, it requires the application layer to select certificates and to select the extensions that go into the certificate. Furthermore, there's no real binding between requests and responses other than the context. So the logic for selecting certificates and selecting extensions already exists in TLS. There's a construct called the certificate request. And certificates in TLS 1.3 are bound to the request. Next slide, please. So with exported authenticators, we came up with a proposed change to the draft, which is a new exported request. Essentially, this looks exactly like a certificate request object. And it will be incorporated into the exported authenticator in that the signature will cover this exported request, if present. Next slide, please. Yep. So that's basically where we are with exported authenticators. There's a PR with comments up on this, and want to raise this, see if there's any questions.
Nick, is the formal model with Tamarin, is that available somewhere, or is it sort of like, did they post it?
Not yet. I updated Cass and Jonathan with the new proposed changes, and so they're working on adopting their model to this new proposed change. And once they have that, it should be posted.
Cool, thanks.
Yeah, so Martin Thompson, one of the reasons why I proposed the change was that in looking at this, there was a number of parameters that were feeding into the hopper. that sort of determined what certificate was being chosen by the other side, and none of those were under a hash, and that made me a little nervous, to say the least. And this actually works out really well from an API perspective, because it means that if you do implement this inside your TLS stack and you're reusing all of the machinery for certificate request, certificate verify, all that sort of stuff, this naturally fits neatly within that model. And you can put the signature algorithm negotiation, you can have that separate, independent from the stuff that's in the handshake. It just seems to work out really neatly. So I like the change.
Right. So this change was recent. It was this week. So maybe we want to see if anybody has read it or if anybody else has any thoughts for or against this change.
What he said. Anybody against this change? Has anybody read it? Oh, I got one. I got two. That's yes. All right, cool. So, I mean, Mike, that was one of the driving use cases was from your former employer. Right? So, I think what we should do is, well, I mean, we'll obviously take it to the list. Do you have a time frame for when you think that the TAMRM results will, be closer to the final?
I don't have an explicit timeline, but they seem to be close, and the new changes, from what I heard, did not seem to constitute a big challenge.
Okay, excellent. Cool. So let's we'll obviously take it to the list. I can work with you to draft up a message to make sure we get it driven home. All right.
Okay, thank you. So it's also to be noted that HDP has considered putting on the list, adopting the additional certificates draft, which depends on this document. So, so there's a dependency there.
Thanks.
Stephen Pryor, just a quick question. So you're using the certificate request, which, if I remember rightly, that's the old one that allows you to specify algorithms or by CA.
That's right. So the TLS13 certificate request, which is just a context and a series of extensions.
Oh, okay. Yeah.
The new one.
All right, no chair hat on. So, I tried to get one of you guys to write this draft, and nobody did. So Joe and I volunteered to write a draft that basically went through and looks at all of the IANA registries, and we need to update them. I want to make sure this isn't a blocking thing for TLS 1.3, so let's get this in gear and get it done. So just talking about the draft. Next. I wasn't sure how much time we were going to have, how long the TLS discussions were going to go, so this is the quick, don't bury the lead. This is basically what I want to do. So we got time. Let's go into the next slide. These are the changes that we made. I mean, the big one was refactoring. So essentially the it's been growing as we put in registry. And the rationale was in the introduction, and it seemed like it would be better to put the rationale for each one of the changes in each of the sections. So we did that. We decided that since we've got this recommended column, we probably better actually explain what it's there for. Then we did did a thing on the list where we figured that we would remove the CCNet cipher suites from the recommended column. They can still be used, they just won't be in the recommended column. We obviously needed to add security considerations, and basically we took the warnings that we had for the cipher suites and added them to every crypto-related registry. Basically, it says warning, don't be an idiot and just implement these things blindly. Actually, look at the algorithm. And we added expert review to the supported groups. And that's really it. So this is mainly a big procedural document. So we're at the point now, next, there's no really open issues in the GitHub repo. So our theory is next. Get Kathleen to start her AD review. Stephen Farrell has kindly offered to shepherd it for us because obviously we can't shepherd our own document. So I'll work with him to get a shepherd review in, and we can get this going. And that's it. Any comments?
How many folks have read the document?
I mean, I'll be honest. I suspect that really what's going to happen is the GenArt review is going to uncover some things because that's what they do. They look at like they care about things like IANA registries. I don't really think that any of you are IANA experts on the registries, so I'm kind of okay with that actually. Yeah. We do have some time, so you don't have to fly through these in 10 minutes.
Hello, Marco Fiolca, I6. I'm going to present the client hello extension against an IO service, and this is intended both for TLS and DTLS, both 1.2 and 1.3. So the problem is that servers are vulnerable to the IO service attack against the handshake, essentially with an adversary that can repeatedly send client hello messages, triggering the server to react in the first place, perform processing, handshake up to given steps, bringing the server to full state open with several half-open sessions. And the cookie exchange complicates the attack performance to some extent, but it is oriented only to non-on-path adversaries. So of course the server is still exposed to on-path adversaries, ranging from adversaries able to at least read and inject messages, for instance, echoing client hellos intercepted before, leveraging at least spoofing possibly, up to adversaries, in addition, able to stop traffic, most likely from legitimate clients, and still hold state open on the server at a later stage. Of course, the specific attack impact is strictly dependent on the specific protocol version and the specific use case establishment node. And this is particularly impactful on constrained IoT devices relying on DTLS and low power and lossy networks. Our goal was to essentially consider also how to counteract on-path adversaries, and we're essentially proposing a client hello extension intended, as I said, for both TLS, TLS 1.2, 1.3, including an opaque handshake token, including basically announce and the MAC completed over the announce. The handshake token is built up by trans-anchoring a trust relation with the server and provided to a client that requests trust anchor in the first place to establish a handshake with the server. Then practically the server has to check the handshake token to be fresh and it's not to divide. And in case it continues the handshake, otherwise it aborts it immediately. Yeah, some more detail on the protocol. The server is associated with one TA only, and they share a long-term key, KM, that is then used by the TA to generate the handshake token essentially. Well, the TA can be associated in principle to multiple servers that have to be registered in advance on the TA, and for each handle server, the TA as a pair with counter ZS initialized to 0 upon server registration, and that is used to build the handshake token as to content itself and MAC computation, of course. The TA receives requests from client interested in establishing a session with the server and has to verify that that client is authorized to proceed with handshake with that server in the first place. And this verification process is out of scope for this document, but can occur locally on the very same TA or out of evidence provided by the client to the TA that the client has obtained beforehand. And of course, communication with the TA, I mean, between the client and the TA must be secure. The specific means are out of scope of this document. While, as we'll see, there's no additional communication needed between TA and server. Yeah, this is just a graphical overview. So you start from TA and that's sharing a long-term key KM. The client requests the TA to establish handshake with server S. The TA generates the handshake token provided to the client on their sphere channel. Then the client starts the handshake with the client hello, including also the TLS protection extension, including entire handshake token. The server verifies that in case of success, the handshake continues as it is supposed to. Otherwise, it's immediately aborted. some more detail step by step. So define the target TA, asks for status administration with us. Then the TA considers the counters at us as token nouns and computes a map on the action of that token nouns as an HMAC using the long-term KKM shared with the server. It builds the handshake token, simply concatenating token nouns and MAC, provides the handshake token to the client, and then implements the counter associated to that server. The token is opaque to the client, so the only semantics you need is agreed between the TA and the server actually. Then the client simply prepares the client flow intents to use to start the handshake with the server, including also the OS protection extension among the other extensions in the client flow, and simply starts the handshake. Then the server receives the client flow. It has to check that the DOS protection extension is fresh using the token nouns, including the extension itself. It has to recompute the MAC and check it against the convened one. And if the match is negative, it has to abort the handshake immediately. Otherwise, it will just continue as it is supposed to according to the specific protocol and version. Yeah, in the document, we cover some additional points. As the session assumption, this extension is not strictly needed for session assumption, actually, because given the existence of the session already, the server is perfectly able to assert client validity. And even possible replays of client hello sent for assumption can be handled by means of other mechanisms like client hello recording. But TLS 1.2 states that at least clients are supposed to prepare client hello messages sent for assumption, including all extensions that they would include if they were starting a new session. So if you want to be kind of compliant with this, and this is so important to consider, the TA can provide a client the handshake token I talked about before, plus a limited number of assumption tokens built up according to the same logic essentially to be used by the client in case of session of assumption. And just for the sake, in the end, to be compliant with that statement in 246. Plus, as I mentioned, when processing the extension, the server is supposed to check that the extension is fresh and presumably using the token nouns, including the extension. In the draft, we propose a possible approach to do that based on sliding window, and of course, it's up to you to arrange a window of proper size so that you can trade off detection accuracy of the playtime hello messages and the memory overhead on the server. Plus, of course, it may take a long time, but eventually the counter ZS on the server wraps around, and in that case, of course, you don't want to reuse KM nonce pairs to generate handshake tokens for requesting clients. So when that happens, the TA must revoke the long-term key with the server, and the specific way you do that is out of scope. Plus, we recommend the TA to enforce a rate limit in issuing nonces or essentially handshake tokens to requested clients to avoid that even legitimate clients can quickly consume the non-space associated with given server at the same time and serve other requesting clients. Yeah, there's a related document actually in the ACE working group working on an authorization framework for constrained environments where details about the transport protocols or the security protocols to be used are left to separate documents called profiles. And there's especially the DTLS profile for such framework that in the latest version has acknowledged the problem and is pointing at this document as a possible approach to address it. That is quite easy to achieve in that profile, by the way, because it is sufficient that the authorization server in the framework acts as a trust anchor of this approach. Yes, the next step, this version is actually a major revision of the previous one we submitted for Prague. The overall approach is of course the same, but we have quite a lot simplified the design and improved the threat model consideration, mostly out of the review we got from Eric. Thanks again for that. But of course, other feedback review are very, very welcome. And this activity was also considered within an EU project about security in smart grids, where we produced also proof of concept implementation of this approach on details 1, 2 in California and Scandinavia. That implementation is aligned to the design described in version 0. So now our next step is, of course, to align that implementation to version 1 of the draft. Thank you.
Ben Kadok. So I've actually read the draft a couple times. I read it a couple weeks ago and then again a couple days ago, and it still left me kind of confused. Your talk today helped somewhat, but it sort of seems like the proposal is to make the DTLS server more robust to DOS at the expense of moving that out over to the TA, and the TA is perhaps still susceptible to DOS. So it seems like this is only useful in the case where the DTLS server is sort of under-resourced and the TA server is heavily resourced and is better able to withstand the DOS test. Is that right?
The TA is supposed to be heavily resourced.
Okay. And then the other thing is that I'm sort of a little concerned about the, not exactly statefulness, but the timeliness. So the client has to get this this token, and it has to use it pretty quickly thereof, because of the way the lack of direct connection between the DTLS server and the TA means that it has to do the sequence number windowing in order to try and detect if these things are valid. And so the DTLS client could get one of these tokens, and then if it doesn't use it for a while, it's stale, and it has to try and get another one.
Sure, but the client is interested in the first place to start as soon as possible that session. Plus, it shouldn't be practically a problem if the window size for replay detection and freshness check is wide enough on the server.
Sure. I mean, it's just there's got to be some tuning going on there in terms of the various implementation limits and the size of the deployment, and I don't think that's discussed very well in the current text in the document, at least.
Valery Smyslov, West Plus, and I think that your proposal just moves the target of the denial service attack from server to TA, because you said that communication between the client and the TA must be secured, and it's most probably will be the TLS, and so we just move the target from one point to another, isn't it?
Comment on that. You can go for alternative techniques than TLS or DTLS that might have other kind of protection against that. But if you go even for TLS or DTLS between client and TA, I find it more reasonable to well protect relatively few where resourceful TA rather than whatever devices can act as server deployed in several higher numbers.
Okay. I just want also to inform you that in IP2 year working group, we have an RFC 8019 for DDoS protection, and it uses a slightly different approach. It is based on client puzzles, proof of work. So it's probably worth to look at this direction too. Thank you.
Thank you.
Min Pai from Semantic. Look at the slide. You said protocol view server is associated with one TA. So many TAs.
Once again, so the server is associated with one TA. Yes.
One TA. So does it shift the DOS from a server to the TA?
Maybe it's like the same question we talked about before. So you're saying we are moving the problem from the server to the TA, essentially.
Right. Because you try to protect that attack, and then that shift to that TS now.
As I say, sure, you need to secure communication between client and TA as well. You can do that with other means that possibly provide other solutions of their own against that. But even if you go for TLS or DTLS between client and TA, I can fairly assume that it's more reasonable to have relatively few TAs robust to read against that, or easier to protect anyway compared to many more devices that can act at servers. deploy much greater numbers.
This is Hannes. So far we had a DOS mechanism added to DTLS already to previous version, and it still exists today with 1.3. And I haven't heard any complaints that it doesn't work, it doesn't fulfill its purpose. So I'm curious whether we are sort of maybe solving a problem that hasn't been out there yet. Did you notice any deficiency with this DDoS mechanism?
Compared to cookie exchange?
Like
it
there's
addresses its own path of
there's the cookie exchange. You do it also. So in difference to in the old DTLS version, you had to add this hello retry request, hello verify request, depending on which version of TLS, and it basically does a return rootability check. It also has a cookie mechanism, which is a useful thing if you to avoid reflection attacks, and also to delay the state allocation and doing heavy computation, which is pretty good in some sense. So did you encounter any problems with that mechanism without actually having to add anything beyond that?
No, it's just that the cookie exchange is limited to non-on-path adversaries. So it's not covering on-path adversaries.
Say that again?
Cookie exchange does not cover on-path adversaries. That's the limitation we're trying to hear. But the two mechanisms can coexist.
Yeah.
Especially 1.3.
Yeah. So you as the other speaker said, you basically move the protection then from the DOS vulnerability to the server and to the DOS vulnerability to another node, because that will also be on path, presumably.
If the secure channel between client and TA is based on TLS and DTLS, yes. And I find it reasonable to do that, because it's reasonable to me to have relatively few TAs quite robust against that, rather than many more even constrained servers.
But it sounds like you're sort of reducing a DOS attack against a distributed infrastructure to a DOS vulnerability against a small number of nodes. That sounds also somewhat tricky, but
so I guess the question is, who has read this draft? Can I have a show of hands? Okay. I won't ask any more questions. All right, now we're up for TLS and TLS.
Hey, my name is Owen Creel with Cisco. So myself and Richard and Max have been trying to solve a problem we're seeing today in deployments. There's two related drafts. So Hannah's actually on the exact same day on October 30th submitted a similar draft, which is for layer TLS, which is essentially application layer TLS. And there's a related draft as well in the Anima group about bootstrapping. And what we're trying to solve here is a problem that's not explicitly solved in the Anima draft, the Brisky draft. So our motivation is this is what we're seeing today. It's a device bootstrap problem we see when customers deploy some of our endpoints and our collaboration endpoints specifically, but some of our endpoints, they unbox the network, they unbox the box, power it up for the first time on a network. There's a TLS terminating middle box between the device and our Cisco cloud, and the device is dead in the water. It doesn't trust the middle box. It has no way of connecting to our cloud, and what we're trying to solve is that problem. The device can't do TLS validation as it doesn't get trust the private CA root on the middle box. So how do we bootstrap? Next slide. There's a few different ways of doing it. The first one is expensive and involves manual configuration. There's a few different ways of doing it. The first thing we could do is we could put operator-specific configuration installed in the device prior to shipping it. So when it leaves the factory, we know where it's going. We put specific configuration on the device. that it will trust the middle box. The second one is the operator disables TLS termination on the middle box to let our device connect to the cloud. That doesn't really work as well. And the third one is the operator has to manually install private CA routes on the device prior to first-time usage. So mechanisms 2 and 3 is what we're currently doing today in our customer networks. No one's happy with that. The operators think it's too expensive, it's too time consuming. What we're proposing to do is work around this via device logic. So what we want to do is establish an application layer tunnel over the middle box to establish a secure connection to the cloud and download the information from the clouds to enable the device to bootstrap on the secure network. The device could simply download the middle box process information using that channel and then fall back to standard network layer TLS. There's multiple different ways to establish an application layer encrypted channel. We could define something using JOS or JWE, JWT. We could define an encapsulation using noise, or we could just reuse the TLS stack and exchange TLS records with the application layer. Our design goal is to do this as simply as possible, as few lines of code as possible on the client and as few lines of code as possible on the server. Our rationale is the device already calls the TLS stack APIs at the network layer. Why not just get the device to call those stack APIs twice? And the second time it calls, it just tunnel that information over the application. Next. So what we're proposing to do is transport the TLS packet inside an HTTP. And transport full flights of TLS records into message bodies. The reason why we're doing this, it's the lowest common denominator. It's the greatest chance of conversing middle boxes, greatest chance of conversing HTTP proxies, and the greatest chance to get to a cloud. That's the real reason why I want to do it, the lowest common denominator. The application or TLS service is just addressed using standard HTTPS URIs. It's most suited to applications that look like HTTP. And as I say, what we're trying to do is just use this purely for bootstrap and then fall back as soon as possible. Next slide. So the architecture is pretty simple. We've this built and functioning using OpenSSL C. We've proven it out using Java PSC as well. What we've seen is the standard TLS stacks all support unplugging the network layer, and we call the top level TLS stack APIs, and at the bottom it throws out full TLS flights. And then you can transport those TLS flights over whatever transport you want, and we're proposing this transporting it over HTTP. The application architecture is pretty simple. You can see it here in the bottom. The application essentially establishes two TLS sessions, one at the application layer, one at the transport layer. And for the application layer TLS session, it just extracts the bytes from the bottom of the TLS stack and shoves it over HTTP transport, which converts the middle box. Next. So there's loads of discussion points here. The most obvious one is turtles all the way down. So we're doing an application layer encryption over the transport layer, and what is preventing middle boxes from trying to intercept that and block it? Well, that same question is equally applicable for any end-to-end application crypto. Whether using noise, if you define something using Jose and JWE, it's the same principle applies. What's preventing a middle box and intercepting that, seeing that, hey, this looks like encrypted traffic, I'm gonna block it. So it turns out from talking to some of the middle box vendors, most middle boxes don't do that because the chances are they break many things. What we're intending doing is just using application layer TLS for the handshake, and then falling back to maybe or using key exporting and encrypted key encoding. Don't necessarily need to do that. So one of the questions we need to ask is, you just use application layer TLS for the 2 round trips for the handshake, then fall back to taking mechanisms, or you could just transport all your application data inside the TLS tunnel all the time. Transport reliability, HTTP messages can get lost. You could just transport TLS records inside the handshake, and that is somewhat mitigated by just using ATLS for the initial handshake, then falling back after your first 2 flights. The transport reliability isn't such a problem then either. And why not use HTTP connect tunnels? That isn't going to work reliably in all scenarios. We have deployments where we have HTTP proxies in front of TLS terminals in middle boxes, so your endpoints don't have to do a connect anyway. And then once it does the connect, it's going to hit the middle box, and TLS virtualization is going to fail then too. And then if you try to do a second connect on top of that connect, well, that's really horrible from the client perspective. It means you have to deploy a reverse proxy in front of your service and hand the connect there, and it will also break middle boxes. Middle boxes won't be able to handle that. And finally, for server to client signaling, you can upgrade to website if necessary. Server to client signaling becomes less important as well if you just use this for the initial handshake for the first 2 working things. Okay, that's it.
Hi, Derek Scarlett. I think people behind me have opinions, but usually I
Right.
don't. I have a question. What happened? So I mean, so HTTP connections are like the lifetime HTTP connection is like really at the discretion of the server, right? And so you pull up the connection and you start doing this stuff, and then the server tears it down. I'm just trying to figure out what's holding that connection alive.
Oh, so you mean how do you do TLS session tracking?
Basically, yeah.
Yeah. Well,
Connection tracking, not session tracking, right? And my point is like you. So as I understand this draft, maybe I just missed something. You pull the HTTP connection. You're basically telling the TLS records over HTTP, right? Which is like Mark may not like, but I don't have a problem with. Or at least for the purpose of this, it's not a problem with. But my point is, you do that, and then you're like sending some data, and the server's like, yeah, I'm like tired of this connection, and it hangs up the phone, right? And now you have to reconnect. And when you reconnect, like you're just back, like you're back to square one, right? Huh? I mean, you could do that. I'm just trying to figure out what is what is the mechanism that do you not care if the TLS connection survives past the termination of the HTTP connection, or do you have?
Well, what you need to ensure is that session state on the server survives until you finish your 2 RTPs and establish your TLS connection, right? And then you can use the export.
If you're going to do the exporting thing, right?
Yeah.
But if you're not going to use the exporting thing, then I actually think you may need TLS con ID to basically connect you when you come back, right?
Well, there's loads of ways of doing session affinity anyway. Local services do that. Local standard ways of doing session affinity.
Session what?
Affinity. Just make sure that you hit the same virtual machine for yourself.
It's not a matter of affinity. It's a matter of from the TLS perspective, when you reconnect to the server, right? So you can just say the lifetime of the TLS connection is bound to the lifetime of the HTTP channel, right? But that's like not really great because what you really would like to have is like that there's no logical connection between the HTTP connection and the TLS connection. And then when you if the HTTP connection gets torn down, you don't have to do a resumption. You just do something else. You just basically say, well, here's like record number 322, and I just said 321, right? And so I'm just trying to figure out
So that's one of the reasons why we think it's probably better just to use the application of TLS just for doing the first 2 round trips, and then do the exporting.
So that might also be fine. I guess I'm just trying to figure out like that's definitely one thing you could say. The other thing you could say is they could use details con ID or something like that.
Mark Nottingham, is that good enough? Like this? Yeah. Oh wow. Okay. So we have a number of efforts in the IETF currently or coming up that are describing how to do things over HTTP. And there's existing advice for that in BCP 56 bis. And we just adopted in the HTTP working group a revision of that, a fairly substantial revision. Yeah. This is probably one of the more flagrant cases there. And so I'm warning you, it's going to be looked at through that lens if you adopt this. I think as an organization, we probably need to work through how we use HTTP a bit more before we get to such an advanced state. HTTP, for better or worse, is becoming to be regarded as a transport by people. I mean, hey, the next version of HTTP is being defined in the transport area. So I don't know if that's good or not. But I think that there are a number of problems here. Having said all that, there is a discussion in the HTTP working group right now about how to negotiate to open up effectively a new tunnel in an HTTP2 and upwards connection. And I think you'd have a much more positive engagement if you went through that kind of route.
I've seen the mail thread about connection potentially using a defining tunnel.
And the exact mechanism is, I think, they're TBD. But yeah, that's right.
Sure. Yeah, I've read that, and that is definitely relatively range that comes out, and maybe that is more appropriate. But let me ask, throw this back to you. Let me ask you a question, right? So like our opening statement for customers with this proposal, right, our opening statement for customers is well, they ask us how do you bootstrap. Well, the first thing we do is turn off the search validation of the network and hop over. And we have to
Sorry, I can't quite hear you.
Our opening statement is we turn off TLS search validation of the network. Right? Straight away, that's how it sets off warning bells, right? So
as well
we're
it
just
should.
So our motivation for this is to be able to point our customers to a standard mechanism of establishing an end-to-end application or crypto session, and maybe a HTTP funnel mechanism will be the right way to do it, but we're just trying to figure out what is the right way to do it.
Are the middle boxes, just curious, are the middle boxes interposed usually, just on port 443, or so can you just use a different port, or are they going to be blocked?
Generally, the ports will be blocked.
Okay.
Right, so different ports. That's why, like, 443 is the lowest common denominator.
Yeah.
And it's most likely to allow us to do this without having to do horribly manual.
Right. And I think there's a bigger discussion that I think needs to happen here, and it's happened in various ways in the past about how we feel about firewall traversal and different mechanisms thereby. Yeah. Okay.
It's whether, there's the flat world versus round world argument, right?
Mohit, so I'm still trying to understand like what's the problem that you're trying to solve. Is like you have a middle box that doesn't know anything about this unboxed client, and you unbox it, and now it wants to connect to some application server from where it will get credentials for the middle box. Am I right?
Correct. Not necessarily credentials to the middle box.
Or some sort of information.
The private CA route was up to the customer.
Right. So I have no information about the middle box yet, but I will connect to a server and get some information about this middle box. So, like, since the middle box doesn't know anything about this new device that you just unboxed, why would it allow you to connect to any application server? Like,
well,
so you're assuming that it will allow some HTTP traffic to go through for you to do the TLS handshake.
Yeah. So what we are seeing is we have customers who have network segments where they will let traffic out.
So I think maybe you need to look at other possible solutions for doing this, and how probably other networks do this is they do it even a layer below IP, so they use EAP, and you can do radius tunneling to any server on the cloud wherever you want to, and send the information about the middle box you want to. I'm just throwing a new idea at you because
Sure,
most gateways do this authentication, right? They do use EAP, and they do use some backend like radius or diameter. Wouldn't that be the better approach to do it than pushing it even further up? Because I don't know anything about this new device that has just been unboxed. So I will only allow it to connect to some server for a little while until it gets credentials to authenticate to me.
Sure. If you're talking about some of the radius and diameter stuff, you need to think about how tightly integrated are the services running in the customer network.
Sorry, I can't hear you. Could you speak?
Sorry. If you're talking about radius or diameter or anything like that, you need to think about how tightly integrated are the servers running on the premise network with the services running in the vendor network in the cloud. So some of those solutions.
I mean, you do a peering, and these are things that are already deployed today, and then define whatever EAP method you need to send the information about the middle box. That's up to you.
Sure, it's certainly worth looking at.
And I would be happy to help you
Yeah,
because this is something that I have looked into in the past. So maybe we can take this offline.
Yeah, let's take it offline.
Also, another offer of help if it's helpful. First, thank you to everyone involved in the Anima Brewski work, having done credential provisioning in factory, key provisioning for a couple billion devices. I think that's really a good way to go.
Also with the middle box hat on though, if we were to expose an interface, or if there were a way that we could sort of authenticate those IoT devices to know that it's just an IoT device, and that it's an IoT device just trying to connect to its vendor, and just make a policy change, if it would that be helpful to have something like that built into the protocol as an option, or are these strictly always sort of an adversarial relationship?
Well, so that's one of the that is one of the options as well, and it's one of the things kind of alluded to in the deck is what we're currently doing today is we're just telling our customers, well, we're not going to tell you. There's no way of advertising our policy. We're just going to ask our customers to whitelist assist with domains so that our device can get out.
Right. So you're doing it based just on domain whitelisting.
We're currently just doing it based on domain whitelisting.
Would you be open to us working with you to do something a little more surgical and a little safer?
Well, so like, well, you've seen Max is one of the names on this draft, right? So, and Max is heavily involved in the Anima, and he's one of the Brisky draft authors as well. And this is one of those specific use cases that isn't explicitly addressed in the Brisky draft. Like, if we do have Brisky compliant networks, then we don't need to do this. Right?
Okay, thank you.
This is Hannes. So I would like to provide a little bit of motivation why I think your work is useful, and I think why this group should take a look at it and pick up this topic, and also what motivates me to write a very similar document, publish it at the same time. I hang around a lot in these IoT groups, and there, in contrast to this working group, people believe that TLS doesn't provide enough security in terms of end-to-end security, so that they would like to extend it even further. And the consequence of that is that the proponents are designing a DLS-like protocol at the application layer, totally from scratch, basically with the same design principles. And that led me to believe that why can't we just reuse the same mechanisms just at the higher layer as well? And the use case I'm looking at is not necessarily HTTP, of course, but co-op and deployments where you have segments along the end-to-end path, which may in some cases not even IP, like you start from a Bluetooth low energy device and go to a smartphone and so on and so on. And it turns out, similar to your experience, that doing that is actually not just possible, it's actually fairly easy and requires very little standardization overhead. So I think this is, I appreciate your effort, and I fully support that.
Hi, this is DKG. So I came here this morning to come to the TLS working group, and I didn't realize I was coming to a support group of people who've been assaulted by middle boxes. I appreciate, so this is all a cat and mouse game, yes? I appreciate your mousing efforts. Apparently we need more mouses, but I don't understand where this all stops. I mean, you've already said turtles all the way down as your first discussion point here. And what you've designed looks to me like a generic stream transport over HTTP. And I may be misunderstanding it. I apologize that I have not read your draft. But I'm not sure why this needs to be TLS specific. If what we're designing is a stream transport over TCP, over HTTP, so that we can stuff an encryption layer in there, why does it need to be TLS? Why does it, I mean, yeah, I mean, it's basically, it sounds to me like you want connect so that you can get past middle boxes that are going to be confused by connect and let you through. I just, you know, we can specify all kinds of mouse protocols, and then the cats can get hungrier, and then we can specify more mouse protocols. But I don't know, like, at some point, I don't know where this ends. Do you have a vision for where it ends?
Well, I'd like to talk about the Connect stuff, because we really don't think Connect is going to work in all the deployment scenarios that we envisage.
Because the cats are already too hungry for Connect. Is that why?
Well, let's take it offline. I'll talk about the Connect thing after this, right?
Okay.
But one of the reasons why we're proposing, like, actually standardizing transporting TLS records is, and also we do intend falling back as soon as we establish trust. Because it's a TLS record, it becomes really, really easy for the middle box to explicitly identify what we're transporting. to see it. They will actually be able to look at the byte stream and say that is a TLS record. I know exactly what this
And so you
transport
think
is
that the
doing.
middle box that's currently rejecting your TLS records, when they recognize that what
No,
you're
it's
actually
not,
transporting
well,
is
the middle,
TLS
no,
records,
the middle
they'll be
box
okay?
isn't. No, it's not the middle box that's rejecting our TLS records. It's just that our device doesn't trust the middle box. Right? We've no way of trusting the middle box.
Right, you're trying to make a TLS record go all the way through to the endpoint past the middle box. And the
Correct.
TLS middle box is rejecting that connection and substituting its own.
Oh, right. Okay. Yes. Yeah.
Yeah?
Yeah. Yeah.
So it's throwing your attempt to connect outbound on the
Mhm.
floor because
Mhm.
it's interposing itself.
Yes.
And you seem to think that
I think the point I was trying to make is that the more common case is that when the middle box interposes itself with the TLS layer, it's authenticating under a CA that the device, the client doesn't trust. And so the client drops the connection. Client, the middle box is happy to let the thing through. Even if the middle box is happy to let the thing through, the client can't verify the server's identity for HTTPS, and so it can't actually get out, even if the middle box is okay.
right. So I understand that, but what's happening is that the interposing box doesn't want you to make a connection to the endpoint. And what you seem to be proposing is that you'll say, fine, I'll connect via your interposition, and then I'll connect to the endpoint, which surely you'll be okay with. And I don't see how that logic follows. You see what I'm saying?
Well, okay. So this is a question for the middle box vendors, for middle box vendors in general. Then, what is their answer to any application or end-to-end crypto? Right.
Yeah. I mean, there's a variety of answers to that question depending on how big of an asshole you want to be. Like, you could go the full like obfusc proxy, like we can obscure this as much as we want, and ultimately they're going to be the cats are going to be in a losing position because of the halting problem or something. So I think the more conciliatory answer that gives me some hope is that in the kind of stages of grief that we're going through here in the support group, this is actually kind of the acceptance stage of grief. Like we are trying to be okay with the middle boxes. But I think Brian in his presentation last night at the patient off talked a lot about how clients need to be able to trust things and adapt their posture. This is about adapting the posture for the network you're in, at least in this use case that Owen's articulated. So that's what gives me some hope that they're because this is designed to make lives easier for both the middle boxes and the devices that are behind them. There may be some possibility of data tolerance.
You have near formerly a middle box vendor. There's a reason that the middle box is decrypting the traffic. It's not because decrypting traffic is fun, it's because the middle box wants to get to inspect the content.
Mm-hmm.
And then if you go and make the content cryptic, well, the first rule of firewall is supposed to enforce policy. And if it cannot understand what's trying to go through, this is weird, and weird, you drop. So by doing this extra layer of TLS or any other kind of crypto, you're marking your traffic as weird and making it so that the middle box is going to drop it, unless the middle box has a specific rule to get this particular traffic to go through, and then you don't need to decrypt it. Like in a business environment, if I bought a new Samsung fridge and the Samsung fridge wants to talk to some Samsung cloud for whatever reason, that's a potential attack. That's something that the middle box wants to get rid of. The middle box is there exactly to get rid of that stuff.
Yeah.
So
I understand that. I know I've talked to middle box vendors, and we are a middle box vendor, so I've talked to our middle box group as well, right? And in general, if a middle box starts to drop any traffic it doesn't understand, that it thinks maybe this is encrypted and I don't know what this is, it's going to break too many applications. The middle boxes don't actually do that in live deployments. If it's a byte stream it doesn't understand and it thinks maybe this is encrypted data, it's going to, and it drops that, it'll just break everything. We got to get out of here. Mark Nottingham. I really like the points that DKG brought up in that this feels like a tactical response to a problem in that you can't get through current middle boxes, and so this is how you would engineer to fix that problem, and that's fine. But when we standardize that kind of has a different bar. This is implying that it is the
appropriate solution for the problem. And you're engineering it this way, as I understand it, because you know it'll get through existing middle boxes, and you're kind of like opting them into that without their engagement. I'd much rather see something with engagement with the middle box community, where you can work out something that's explicit and that has a future, rather than just what feels kind of like hope-based engineering. You're hoping that they won't decide, oh, we're going to block that too. And so yeah, I still have a lot of concerns, and thanks to EKG for that perspective.
All right, so just so everybody's clear, we're not going to have a working group adoption call in this draft. There's obviously more discussion needs to happen. Do that. I have no problem using the TLS to do that. Gentle reminder, you need to go. There's a thing in here, so thank you for your time, but please expedite leaving the room. Thank you.
So I gotta do that.